and thank you for your patience. We have realized that people are thinking that the program starts at 9:30, so people will be joining us as the program goes. But without further ado, we would like to start the day 2. So first of all, for our Korean participants here, I have it written here by our lovely teammates. It's 여러분 좋은 아침입니다. 환영합니다. For the ones that did not understand, I just said good morning, everyone. Welcome. And yeah, welcome back to the second day of the Nexus Forum EU South Korea Digital Convergence Week. Yesterday we had a really nice and fully insightful day where we covered the policy part of the Nexus Forum and its impact. And now we are having the second day where we'll be focusing on research. And I would like also to change the next slide, which is not possible from here, sorry. For the ones that do not know me, my name is Daniel Pavlica. I'm a project manager at F6S, and where we are incredibly proud to co-organize this event as part of the Nexus Forum project, together with our partners from RISE, from Technalia, from OpenNebula, Martel, Mage University, and of course, Yonsei University. I would also like to thank all the speakers and participants that also joined us yesterday, and welcome everyone to this synergy that we have created between European and South Korean research, policy, and industry. But enough of me talking, I'll be talking the whole day. I would like to invite to the stage Maria Angeliki Evliati, Senior Project Manager at RISE, and our Nexus Forum Project Coordinator to officially kick off our second day and to welcome our speakers and other participants. Maria Angeliki, the floor is all yours.
Turn it on. Okay, great. Good morning, everyone, from my side as well. Welcome back to day 2 for those of you that were with us yesterday. So just a very brief recap of yesterday. We laid the foundations, reaffirming the why European and South Korean collaboration in digital infrastructure matters, and how we can complement each other. We also talked about the barriers that need extra attention to enable this collaboration. And today we will turn our attention to the what kind of technologies we would like to focus on beyond Cloud-Edge-IoT. And we will be firmly focused on the emerging and strategic technologies and how EU and South Korea can continue learning from each other on these levels. I will not say a lot more. I will hand over to my colleague Thomas Olsson Timodas. He's a researcher in computer science, and he will tell you a bit more about how the key takeaways of today will feed into the technology and research roadmap we are currently finalizing, and we will be sharing with the European Commission by the summer. So thank you very much for joining us here today, and handing over to Thomas.
Okay, yeah, okay. Thank you very much for the introduction. So I'm Thomas Timodas. I'm a researcher at RISE, and I will talk to you a little bit today about how this event will feed into what we're doing in the project and the roadmap that we are creating in the project. So it's I think we're still waiting for more people to come, so I will maybe do it a little bit more like interactive, or what you want to say, so maybe involve you a little bit more. So this event, why we're here, the project Nexus Forum, it's about bridging these ecosystems, right? The computing ecosystems in Europe and also between Europe and South Korea, among other countries. So it's really about shaping this research and innovation priorities for the coming years in Europe, and the shared priorities between Korea and Europe as well, to feed into this kind of decision process, what kind of things should be funded in the future, right? So these discussions that we're having here are really important for us, because it gives us insights into what is happening in South Korea, what's important in South Korea, how can we take this into account and propose funding programs, calls that align with the interests of both parties. Because South Korea is, as you may know, also associated now with Horizon Europe. So you really can get money for this kind of research collaborations. And one of the things that we, like the tools we use to communicate this to the European Commission, is a roadmap that we are creating in the project, right? So the European Commission, when they gave us this project, it was one of the things we should deliver, a roadmap for the future of this cognitive computing continuum. I will tell you what it's about very soon. But you can see what we will talk about today is AI, cybersecurity, open source supply chains, 6G future networks, quantum, and of course, chips and hardware infrastructure architectures. So the roadmap is an important input, as I said, for the European Commission. Now the Horizon Europe program is closing very soon, in 1 or 2 years. So it's about, so the roadmap will help kind of give input to the Commission. What should we kind of, how should we round off this program, and what should we prioritize in the next program that comes after Horizon Europe? And we have one version that we published a little bit more than a year ago, and then we will do publish the final version in the summer when the project ends. So I said cognitive computing continuum. I think it's one of these buzzwords, right? I don't know if it means something here in Korea, but the idea is that you have a kind of AI native continuum, you know, from HPC cloud spanning to edge IoT. Like, how do you make this a seamless infrastructure, right? And from a European perspective, it's important because we want to reduce the reliance on hyperscalers, right? We want to reduce vendor lock-in. We see this growth of IoT. You generate data in different, I mean, at the edge, right? So why not bring also compute to the edge? And I know there's a lot of researchers here working on edge, so I think this resonates well with you. And of course, telecom is also under pressure because of hyperscalers and other things. So how can they make new business? How can they become part of this infrastructure layer? And Europe is also strong in HPC, right? We have a very good HPC ecosystem, but it's for scientific computing, right? It's not made for developing AI. So now there's also a shift in Europe that the HPC ecosystem should support AI. So we have these AI factories coming, and even AI gigafactories, like 100,000 GPU compute clusters. So the roadmap, the first version that we published a year ago, you can see it has this kind of AI for Cloud Edge, Cloud Edge for AI. It's basically, you know, how do you optimize and manage, orchestrate in this kind of new infrastructure? And how do you support AI in this new infrastructure? How do you integrate telco in this new infrastructure? And what are the main use cases? And there's a QR code, you can scan it, and I think there's some business cards outside with the QR code for the roadmap as well. And then we have some things that are for the future, right? Neuromorphic, quantum, space edge, I don't know how big satellites and space are in Korea, but in Europe it's a pretty big deal, and it's considered one of the future frontiers, right? It's one of the next races, global races. So, and as I said, we are creating this final version, and I wanted to highlight a few things that are changing in the new version. So we are restructuring it to be more clearly about, the priorities. It should be clearer. And since we sort of started the first roadmap, which was in the beginning of 2024, so the assumptions that we had then, what we should deliver, and what has happened as a result of this kind of AI, explosion, the assumptions have changed, right? So we are also integrating these changes more in the last version. So of course, agentic AI and it's becoming, is really growing and is changing a lot of the assumptions for the infrastructure. So really the roadmap is also a little bit more centered around AI. That was not really the case in the first version. And I said also that, one of the important things when you make a roadmap is it shouldn't be just the thoughts of a few individuals, right? It shouldn't be the ideas of just a few. So it should really include ideas from the community, different communities. It should be validated as well from in the community. So we have these working groups that we use as a mechanism. Now that's the official version, way to influence the roadmap. If you want to join, you can scan the QR code. Of course, now it's kind of not that much time left, and you have time zone differences. But today is really, that's also why we're here today. So the things that we talk about here, we will bring home back to Europe, and this will also be integrated in the roadmap. And if you're interested in giving some, feedback on the roadmap, you can also reach out to me. We can share a draft with you, and you can give some comments. So I think that's what I wanted to say today. Since we started a bit late, we can also finish a bit earlier, but I want to open the floor first, if anyone has any questions about this. Yes, there is a summary in Korean of the first version, yes. I don't have a QR code, but it's also outside, I think. Yeah. Any other questions? No?
Not. Thank you very much, Thomas. A round of applause for him.
Thank you.
And all the work that he has been coordinating to produce the roadmap together with all the consortium members and stakeholders. So thank you very much. Now we move on to the first keynote of the day, from a person that brings a wealth of academic and practical expertise to the stage to discuss emerging technologies and the future of EU and Korean research collaboration. Please welcome Professor John Suk-Yo from Yonsei University with a huge applause. Okay. Welcome.
Thank you. Thank you for your nice introduction. I'm a faculty member from School of Integrated Technology in Yonsei University. Today I'll talk about the emerging technologies and the future of EU-ROK research collaboration. I have to explain this. The animal symbol of Yonsei University is eagle. That's why we have this slide set here. So I'd like to welcome you to Yonsei University, explaining a little bit about, since you are in the international campus, I'll talk about a little bit. And then Yonsei Science Park Innovation Ecosystem, I think you will have a chance to go over and actually look around what that is. So I'll provide a little bit of information there, and then emerging technologies in AI, semiconductor, quantum, and then bioconvergence and sustainability. And then they'll briefly talk about future of EU-ROK research collaboration. So the excellence, in terms of excellence, it's 140 years oldest university in Korea, and we maintain 3 campuses. As you can see, there are a lot of interactions internationally, and the international, the publications and research funding, etc. And we are top 250 in the world. Is in terms of QS university ranking, in terms of interdisciplinary research, and then #1 university in Korea, and then 30th in the world. And this international campus is really focusing on interdisciplinary and also convergence and innovation focus. So many of the academic disciplines made here is actually established with that vision. So we have about 700, over 700 partner institutions with the bilateral agreements, and the international community, international students, about approaching 6,000 students, and with the student mobility, constantly happening within the university. And then offering international summer schools. So there are a lot of international programs, participating over 2,000 students in 2023. And then we offer the #1 online course programs. So learners.org, if you go there, then open courses. So these are all the design infrastructure to facilitate international exchange. And then we'll talk about Yonsei Science Park innovation ecosystem here. As you can see, I'm just showing you, GDP comparison between United States and European Union. Interestingly, EU and US, they have been tracking similarly until like 2010, and then after that, there is a deviation. I think that's one of the reasons that we are gathered here to figure out. And there can be many reasons, but of course, the United States, they are abundant in terms of natural resources and etc. But the main reason, I believe, is they have this science park or research park with the organically integrated university industry ecosystem. And for example, there have been waves of innovation every 10 years in Silicon Valley, continue to push the innovation to the next level. And at the heart of the Silicon Valley, there have been Stanford University and public-private university system, and then public university system, UC Berkeley, having a healthy competitive relationship, and the Stanford alumni and faculty combined, 5.4 billion jobs created in 2013, and more than 200 unicorn company, billion-dollar companies, generated $2.7 trillion annual revenue by 2013. So these are all the things that we know, but we have to understand how that system works to promote new, novel innovations, etc. So you have to have a talent pool generated from the university, and then going into and developing the culture, the entrepreneurial students, and then risk tolerance culture and venture capital network with the legal system design, so that you can have a continuous innovation flywheel from talent, ideas, and capital and scale. And then supportive culture, the failure is a graduation in that supportive culture. So with that spirit in mind, and we believe that with the kind of power shifting from Western culture to Eastern culture, that we believe that the similar type of ecosystem is fairly important in Asian countries. And with that in mind, that we decided to invest, Yonsei University invest in Songdo. So this is the picture showing 2006, the Incheon, the area that you are sitting here used to be ocean, okay? So there was nothing, right? It's just a sea. And and then within 20 years that you see all these buildings in this city. The strategic point for this city is the it's within 4 hours of flight, there are access to about 150 cities with 1 million inhabitants or more, so that it can be strategic location. That's why and then we developed this Incheon Free Economic Zone, IFEZ, and you can look around when you have time. You can look around the city, and if you go to this building, then you will oversee the Central Park, and then this is the daytime and then nighttime view. It happened within less than 20 years. So here on this campus, we have this concept of Yonsei Science Park innovation ecosystem. So you have a phase 1, educational departments, and then phase 2, we are expanding into this region here. Within Songdo is well known for biocomplex, producing about 6% of biosimilar products in the world. So this is #1 city in terms of biosimilar products. You have Samsung Biologics, Dongha Social Groups, etc. So we have this biocomplex. K-NIBERT is the educational institute. Initially started from Ireland, and then we imported that the program, and then started this K-NIBERT program here. We installed the quantum computers, and then School of Integrated Technology, the department that I belong, and then Professor Go sitting there. So in terms of innovation ecosystem, when you look at Silicon Valley, there is a healthy relationship producing all these talents here. And then we also have the innovation ecosystem here. The Yonsei Science Park is here. And then Seoul National University is located here, the public university. But main difference between two universities is Stanford and Yonsei, established in 1885, fairly similar, so over 140 years of history. If they did it, and then we should be able to do, right? The main difference is the United States was far ahead before, and then Korea is catching up. And then, now that Korea is doing very well in many different areas, industry. So I think we are ready to do that. So Yonsei University have a shield and eternal flame symbolizing freedom. And then freedom is very important source for creativity. And then as you can see, we have first academic winning director, Bong Joon-ho, alumni of Yonsei, and then Nobel Prize winner in literature in Hangang. She is also Yonsei alumni. So these are the first that we have done in the past. School of Integrated Technology, we started with the integrated information technology and then expanding to intelligent semiconductor technology as well as mobility systems. And so these are the big research programs we are spearheading. The strategic establishment of these departments, you can see conventional departments like electrical engineering, material science were not enough to address these interdisciplinary nature of the new businesses industry. And you can remember this gathering in Kambuchikin last year in APEC 2025. And Jensen Huang came over from NVIDIA, and then he met with Lee Jae-yong, CEO of Samsung, and then Jung Hee-sun from Hyundai Motor Company. There is a reason for such meeting, right? They are correlated in terms of AI and then semiconductors and high bandwidth memory and then future mobility systems and physical AI. So in terms of departments, we have within our School of Integrated Technology, we have Department of Integrated Information, Intelligent Semiconductor Technology, and Future Mobility Systems. So those are match to industry. And also we have a contractual department on mobility systems and also semiconductor devices as well with Samsung and Hyundai. So let me talk about emerging technologies. So when you look at the industry 1.0 to 4.0, humans are becoming more like machines. We are trying to understand how machine works, etc. And then machines becoming more like human. So from 1.0 with steam engines and steam power, electrical power in 2.0, and automation with all these ITs, and cyber physical systems in Industry 4.0 with the IoT and AI and big data. So in terms of IT, we were selling computers to big companies, and then we started to sell to households, and then we started to sell to individual people, right? And then we started to sell to things, and that's IoT. And then we are now selling to robots, physical AI. Then who's going to buy afterwards, right? Because the robots are replacing human, and then how there is no income source economy, circulating economy that we have to sustain. So we have to think about what comes after Industry 4.5, 4.0, so 4.5, 5.0, for example. So that's a human AI symbiosis that we have to go for, and then there has to be methodology that we are approaching. The AI, in terms of AI, global AI market, I don't even have to talk about this. That's a whole theme. But in terms of technology readiness for Korea, it's currently ranked at like a 6 or 7. And with that, we are understanding how AI works, and many applications, imaging and media, networking, and the mobile system and sensorics, and the AI chips, cars, and quantum computers, etc. So we are establishing Yonsei EU collaboration platforms, and in terms of human exchange, and we established a relationship with EUROK in France, and then Technical University of Dresden in Germany. And then this Horizon Europe project is also spearheaded by Professor Go on cognitive computing. Cognitive meaning that's computing things like human, right? So this is one of the example here that I think Professor Go is spearheading, core agent enabling agentic AI across cloud-edge computing continuum. So I think that's one project with the participating institutions from Europe. And also another main effort that in our department, Professor Che Chan-byung is leading this 6G Cloud R&D Open Hub project funded by Korean government, about like 20 million, $2 million a year. Kind of funding for several years. So you can see that the EPFL and the UCL, and there are some University Oulu from Finland, and the EUROK from France, and the King's College London from England. They are all participating in this. And when we talk about global semiconductor market, of course, the AI is important, but the enabling AI requires the chips. So semiconductor market, I don't even have to go through these numbers. They are always a hockey stick. So optimistic scenario or moderate scenario that will hit the $1 trillion industry by 2027. That's why the stock price for Samsung and SK Hynix are so high these days. Many of them are new businesses related to the AI network fabric. Korea is in playing a big role in this global semiconductor market, covering about 50 to 70% of the memory devices. And then there's much less system semiconductors, optical disc components. In terms of HBM market, high bandwidth memory enabling GPU and AI infrastructure, we are covering about 80% of the whole market. And so that's something that we can leverage to continue. Many of the packaging technologies go in there to enable such products. And within Yonsei, we have this integrated semiconductor innovation with the semiconductor fabs and that's characterization center. So we fabricate chips and characterize and model those devices based on quantum computing capabilities that we have on this campus, and then computational modeling using density functional theory and and the hybrid computing approach. So in order to enable semiconductor industry, you need to have a strong materials, components, and equipment capabilities. And then we also had Yonsei University maintain a good trusting relationship with Fraunhofer IKTS from 2015, and then continue to do many of the projects, and that led to a big project last year. So establishing a Korea Fraunhofer Collaboration Hub for Science and Technology, so-called KFAST Hub, with the funding from Korea. So they are engaging, Fraunhofer has about over 70 institutes, and utilizing that relationship, we are Korea is having a collaborative relationship with Fraunhofer in many different areas here. And the global semiconductor materials market reaching USD over $100 billion by 2034. And then semiconductor manufacturing equipment market is also hitting twice of that size. So it's also an important market. And then we are trying to address that. And the talking about AI and then semiconductors, fabrication technology can be applied, and then AI can be applied to enable a new type of biotechnology as well. So bioconvergence is also important in terms of digital healthcare, remote health. So AI-enabled health system with the personalized care, and then cell and gene therapy can be investigated based on AI. So one of the project I'm doing on Eurostar is the Yonsei EU joint case, research case, biosensorics for point-of-care testing. So engaging Fraunhofer IKTS and working with some small, medium enterprise in Korea, and also small, medium enterprise from Germany. Now from Minden is the company, and then clinical evaluation is done by Severance Hospital within Yonsei. Another example is Korea-Switzerland Innovation Program. So having this relationship with the EPFL in Switzerland, we based on quantum tunneling devices that we are able to come up with a novel biosensing, self-illuminating sensing platform, and publishing the results in Nature Photonics. And then there is a lot of EU collaboration. I talked about K-Nibert, originated from Ireland. And then there's additional the collaboration that we hope we can initiate through this collaboration here. And then quantum research trends in Korea, we can leverage. There's a lot of strengths in terms of leveraging existing IT infrastructure, etc. But we are kind of weak in the area that we have not really invested comparable to advanced countries in quantum science and technology, and that we are gearing up quite a bit, and for the past 2 to 3 years. So there's a lot of activities and funding, and that's one of the reasons that quantum area that we asked Horizon Europe to require Korea as a partner to initiate some of the Horizon Europe project. And as you can see, the quantum fabs are up and coming, and some of the standardization exchange is happening. So there are strategies that we come up with for quantum computers and quantum communication and quantum sensing, and there's a detailed strategy that we are putting out there. In terms of Yonsei University, we have huge initiatives on quantum computing, make a huge investment. So we are the first university, we are the first institute in Korea installing a quantum computer. So IBM Quantum System 1, 127 qubits. And then we have this Yonsei Quantum Complex. If you go out there, you can actually see the quantum complex with the quantum computer. We are having routine Yonsei Quantum Week forum, and the quantum expertise. We are starting this several institute organization within Yonsei University, and then having a global quantum network with many institutes across the world. And in terms of specific area of research, my group is leveraging quantum computer to understand how amorphous semiconductors work for neuromorphic computing. So there's existing HBM, high bandwidth memory and GPU, and then in-memory computers, and then neuromorphic computing, and then in academia we are working on neuromorphic computing devices. And then also there's existing collaboration network we leverage to understand how quantum hardware works for some of the quantum computing technologies. So in terms of sustainable technologies, which is very important, planet Earth has existed for so many years, billion years, and then compared to that, human only exists for like 400 years, 400,000 years, and so we have to learn how to be sustainable from nature. And then I know the European Union has long history and tradition to understand how it works. So we like to learn from that. So EU Research and Technology, there have been a lot of efforts and philosophical approaches, and we like to understand and leverage that learning to implement, to make AI more sustainable. So one of the approach I'm taking is based on Human Frontier Science Program funding, headquartered in France, and then collaborating with the College de France and University of Ghent researchers working on structural collaboration based on nature-inspired approaches. So with that, the future of EU-ROK research collaboration, I'd like to make a few comments here to end. So symbiotic integration of AI and human is required beyond Industry 4.0. So how can we stay symbiotic between AI and human? AI, there's a way to avoid war and then coming up wise with AI, but instead we are utilizing AI to hit the target, right? So we can, the way we use to, in the wise way, that's the thing to go. So the nature-inspired sustainable approach is required for emerging technologies. Education. It's, we have to maintain balance between excellence and equity for entrepreneurship and democracy, right? So Korea is well known for educational system to level up the average people, and then that's how we enable, fast follower strategy to come after all these advanced technologies. But now we have to be a first mover. So we have to aim for excellence. I mean, that's what the US education system is doing well. But in terms of equity, I mean, they are falling behind in terms of average people, education, and I think that's where EU is excelling. And, but we have to understand the political system has to work based on democracy, so education for average people are really important. Ecosystem for responsible and sustainable innovation, the legal, financial, societal, and entrepreneurial systems. And then the next one is a global innovation ecosystem. So the university serves as an open innovation platform for the EU-ROK collaboration network of academia, research, industry, medical, and government. So we have to work together as an ecosystem. So that's something that I wanted to conclude with. With that, thank you for your attention, and then I'd like to conclude my talk. Thank you.
Thank you very much, Professor Yok. 감사합니다. Do we have a question for Professor? Oh, there is one question.
Thank you for your presentation. Talking about quantum computing, I see that you have an IBM computer here.
Right.
But I remember to read that you have also an agreement with D-Wave, but and that you are going to deploy also a D-Wave computer. But I don't know if I am right or if it is going to be in this campus.
So IBM Computer, we physically have the system on campus, and then that's the more like a proprietary platform for accessing and understanding initial platform to quantum computing. There are like several different techniques, and the D-Wave computing system is good for the quantum annealing. The individual quantum computers are not yet for mainstream. So there are several computing technologies based on neutral atoms and ion traps and etc. So we have this relationship with many different quantum computing companies, and they're having some agreement to collaborate. So we can leverage their platform to do computing, but we have this exclusive relationship with the IBM quantum computer because we house them, we have them in-house. Does that answer your question?
Yes, more or less, because so in the Basque Country we also have an IBM, but in Tecnalia we have access to a D-Wave, but we don't have a D-Wave computer.
Yeah.
So my question is that if you have any agreement with D-Wave, if you work with D-Wave or you only work with IBM?
Oh, well, we do work with other outfit as well, the quantum outfit, IonQ and D-Wave, and depending on how individual faculty members' requirement arise, and so we have those individual agreements.
Okay, thank you. I am asking because I think that this could be a good point of collaboration, because we in the Basque Country have a huge quantum ecosystem and we are searching for collaborators. So, thanks.
Right, yeah, I agree.
Thank you very much. Once again, please, huge round of applause for
you.
Professor Yao. There was another question. Yeah, we can take another question before we moving on. Thank you.
Yes, hi. Thank you for that. Yesterday, in my presentation, I also talked about a shift in Europe from regulating to a more interventionist industrial strategy. And I think this is where we have a lot to learn from Korea. And I thought there were some very interesting slides there about this kind of systemic thinking about how we can become excellent. Korea can become excellent in a field, and having a vision for achieving, for example, excellence, global excellence in quantum computing, for example. And I think this is where we have seen in Europe, these visions, these compasses, etc. And then, but maybe we are lacking this kind of systemic thinking. And I was just wondering, because you as a professor of a university, you present this more, on your slides, you had more societal, you have this kind of self-awareness of how you fit into this societal plan and maybe within a kind of national strategy. So I'm just wondering, is that, how present is that thinking in your work? Do you see what I mean? Are you aware from a kind of government level? Is there a sort of, how does that work, that you are, as a professor, you're aware that you're part of a national strategy in this way? Are there meetings, institutional frameworks that kind of insist on keeping this top of mind for you?
That's a good question. And so spending like 20 years, pursuing advanced degrees and stuff, and having spent some time in US for all these companies, high-tech companies, and then coming back. And when I talk about innovation ecosystem like 15 years ago in Korea, and then nobody was listening. And so that concept was fairly new. But these days, everybody's talking about innovation ecosystem. So it takes time to, cycle of learning to go through the organizations as well as the nationwide to go through that learning process to recognize the importance. And then ecosystem especially is a very difficult word to digest, but that's how they become successful in Silicon Valley. And but geopolitical system may not support that anymore. So that's the opportunity for Korea and Europe to catch up, right? So I think there's a lot of opportunity out there, a lot of good work being done in Europe. Okay, so but we have to take that out of the laboratory from academia to commercialize some of those technology. But I'm not sure whether that system is there to promote, researchers out there and pursue other opportunity, because it's considered unconventional. So researchers have to take risk, and there's no recognition until they actually succeed. So they are not willing to take risks, and that's the thing that's different in United States. So we have to promote the culture, that really promoting the innovations. And that's the system level, and I'm not sure how willing Korea or Europe are willing to do that. But that's what we have to do. You saw this GDP comparison, how innovations, really making impact in market. So that's something that I think we are all gathered here today, right?
Thank you very much. Okay, great insights. One round of applause again. Thank you. Continuing with our exploration of the collaborative future between our two regions, our next keynote speaker focuses on the power of scalable systems. And so please welcome the Director of Scalable Systems at RISE, Stefan Vendin.
Amazing. So I head up something called intelligence system, but I'm not the one to be picky here. But there might be other parties that would be. So as all of you know, when you are to start a session or a story in Korea, it all starts way back in a time when tigers could smoke. I wasn't intended to do this in Korean, but my Korean girlfriend told me, please don't do. You will make a fool of yourself. You will embarrass entire Sweden and Korea because she says that I sound like a rice cooker. And this is the thing I practice my Korean with. We have a lot of Korean appliances, and then I mimic them at home. So it will be in English, but we can always try it afterwards. So my name is Stefan. I head up intelligence systems, partly one part deep learning, one part language. And I usually bring this to the start because for every complex problem, there's an answer that is clear, simple, and completely wrong. So I guess there will be slides today, so I will mostly be wrong, since it's very hard to elaborate on slides. But with that said, let's dive in. So I have a long time. I spent majority of my years in building the label property graph space at Neo4j, Sweden's most secret unicorn. Do we know Neo4j here in Korea? Good, we're still secret. I wasted 10 years of my life building graphs. But I did work with some interesting things, helping NASA go to Mars, catching a lot of bad guys in FinCEN files, Pandora Papers, Panama Papers, and so on. Then I noticed that Sweden got worse and worse in AI. So I decided to move home from Silicon Valley, and I started at AI Sweden. I very quickly start to be annoyed that we did only PowerPoints. So then I find the home at RISE with researcher actually writing code. Very good, I was thinking. So with that said, let's jump on. Majority of what I do is literally this. I'm there doing some sort of analytics, some AI. I complain about the data because the data is always what? It's always good. We always talk about how fantastically much data we have, and then they show me the data, and yeah, it looks a little bit like this cake here. It's horrible. One of my most common sentences is Excel is not a database. But with that said, let's keep going. So I would like to use this quote to kind of frame it. We don't see the world as it is. We see it as we are, right? And I think this is the power of collaboration, because it allows me to borrow your mind, your way of looking at the world, and I can see my thinking in your eyes. And this is how we as two nations, individuals, can grow together. And to quote, I think it was Sachiko saying this yesterday, partners that can teach us something, and it was ... I didn't catch all of it, but I thought it was very, very interesting. And this is also why I have, for the last 10 years, tried to get collaboration between Korea and Sweden, because I fell in love with many things, and I thought I'd share some of them with you here today. And then I'm gonna try to brag about Sweden. For a Swedish person, this is very uncomfortable. So when I stumble on it, you will just laugh, okay? So one of the things that I thought was amazing was this winter I was here as normal, spending time in Shannon with my girlfriend and her parents. And my friend at Upstage, one of the language labs here, had a little bit of a trouble or a large accusation about their latest model and how it was just a Chinese model that they post-train. Okay, this is an accusation, okay, but how they handle it was amazing, I would say. So they publicly published all data, invited everyone to try out collaboratively together. And this was in days. I mean, it was all over the news, and 3 days later, everyone was there comparing data, comparing notes, figuring out that it wasn't actually true, it was just a false accusation. But the way the community come together, solved it, is something I have not seen. I would definitely not seen it in Sweden. I would absolutely not see in the US. It's rather the opposite. We almost kick on each other and trying, now you're in trouble. But all of a sudden, everybody worked together. And I think this is something that I think is really, really, really nice. Another part, which is also very fun, is every single time I met with the people at Furiosa, Upstage, Squeeze Bits, and so on, I noticed also that when I speak to the CTO or the technical side of the company, they're equally competent on pitching the business ideas, as well as the business person is equally competent at pitching the technology. Oh, I got the laser in my face. It's fun. Okay, sorry. Easily distracted. This is something that is very unique. I haven't seen it anywhere in the world, so this is a very good inspiration for me. So let's jump in and brag about Sweden, shall we? What we're really good at in Sweden, apparently, is crunching out unicorns. If you look already over here, we are almost best in the world, right? If you do it according to GDP. Well, it's also very interesting that we're actually very good to take them to IPO also. I'm still angry that Neo4j has not done IPO, so my shares are still sitting there waiting to give me money so I can retire and build my own research center. But I think this tells a story which is very interesting, and this has literally jumped the last years, of course pushed by Lovable and Legora with Anton and Max and so on. But I think there's some story here that is interesting. We see public recognition. We have Y Combinator even opening in Stockholm office, which is kind of weird. So the world's best accelerator is opening in Stockholm, which is kind of a strange thing. With that, we try to take opportunities. So a second part, which is slightly secret of my work, is that I'm leading the consortium with RISE Eco Data Center in Mistral to get one of the gigafactories here in Borlänge. I will say this is a fake image. All of the nature and the hydro plant is correct. So this building is AI generated. But we have started building it, but it looks like a building site, so it's not pretty at all. But what we're trying to do is make sure that we have a very interesting site. So we have renewable energy. We also have the largest kind of heat reuse. So putting all of the power or heating from the GPUs back into the district heating. This is a perfect opportunity for us to build. So when we start, we're going to have, if we use this kind of Jensen Huang's AI cake, we're going to have kind of energy chips, infrastructure models, applications, and so on. And there will be spaces in between all of these for either us to sell or build to sell or use for others. So this is also a very interesting collaboration opportunity for us together to start doing that. And of course, all over Europe, not entirely in Sweden. There are going to be 5 of these as the latest news in Europe. So we are trying our best in Europe to kind of pursue this. But let's talk about being wrong, my favorite thing. So a model can be 99% confident and still be wrong half of the time, right? And the reason for that is that we have this idea of this confidence score, mostly and most times from the softmax layer, right? The problem is that that's just a raw score from the model. It's not a statistical guarantee, right? And you all know this. So we could use this old George P. Box quote that all models are wrong, but some are useful. And if all models are approximation, essentially all models are wrong, but some are useful. However, the approximate nature of the model must always be borne in mind. So the practical question is then, how wrong do they have to be not be useful? And then we have a little bit of magic mirror, mirror on the wall. Who is the most competent agent of them all? So if we look on this agentic space, right? There's a lot of talk, but they're just going to be as competent as the data they're trained to navigate. So reasoning matters, but performance depends on signal quality, contextual access, and feedback loops. And here again, we are in the space that what I see very often coming from not the research field. I never had any data that was not shit. It's always shit. It's always going to be shit. When I worked in statistics 20 years ago, it was shit. Then I started doing data science, same thing, just new name. It was still shit. I'm doing machine learning, still shit. It was keep going like this. So I'm pretty sure it's just going to be going for this forever. So what we need to do is kind of figuring this out and how to build it. That's how we do it in industry. Because in the lab, it's very easy to control it. But in real life or in the wild, it's going to be kind of horrible data over and over again. So with that, I'm going to take a little bit of an experience because I got slapped in the face. I was away from building companies in Silicon Valley for 1 year. And oh my God, how things have speeded up. So I was invited by my old colleague, William, at Neo4j. We were presenting at a conference this idea of building or using Neo4j as some sort of a memory storage for LLMs and agents. So we have kind of short-term memory, meaning we have a message and we have threads in that message. Then we store kind of user preference, categories, and so on. We store reasoning. We store tools and tool calls and so on, which creates a very structured way of understanding how and what the models are actually successfully doing. Then we had a stupid idea, because this is literally cleaning up the data for us. The more people use it, the more we know the quality of data. What if we can just get a research project and kind of build this out and then train models to be better at navigating this structure? If we can do that fast enough, every single company of scale can do that for their own company. Great idea, right? Or so I thought. So I went home. And I was lucky because there was an open application at Vinnova. Usually you have to wait for finding the right one, and that's like half a year. But this time I had 5 days to find one. With that said, I wrote that application. Then I'm waiting. I'm still waiting to get the result. So here's the end of the presentation. No, of course not. That was a bad joke. I tend to do bad jokes. There's only one person laughing, so I know for sure they're bad. So what happened here is that my friend William, as I was very happy here saying, oh, I've written the application and submitted it. He said, oh, I already built the whole thing. I put it on GitHub, so let's see if we can get some clients. So in parallel, we built a system where we have actually confidence scores for every single part of the query. We have a history, we can traverse it, and we can store it, and we can see it validate over time. And then I was thinking, oh my God, that was fast. That's 1 week or 1 sprint. I'm still waiting. I didn't hear anything. And then, poof. Apparently now it's hard to see, but with 1 line of code, you can launch this for yourself. I'm still up here. I'm waiting for Vinnova, which is to even get back to me if it was a good idea. They already built it, published it. So we're already now pre-training the first model that we tried with Ericsson on the data before we have an answer for this. And the reason for this, I would argue, comes from how easy it is to build things nowadays. I remember early on, this is the early days over here. I remember working with Novo Nordisk, and we had this stupid idea, what if this GPT-3 could help us write Cypher, which is a query language for NEO. So we built a large knowledge graph for them, and then we were thinking that maybe that could work. It worked horribly bad, but it worked. Then it was kind of flat for a while. And then something happened the last kind of 6 months-ish. All of a sudden, they started to become insanely competent. I started to become the bottleneck, almost. I can run parallel terminals working together, and it was literally just insane how efficient it all become, right? So this is the reason why they can already be so fast in the previous slide. So I think what we then notice is that around February and early March, it started to become very bad. Did any of you notice this working with Claude? All of a sudden in early March, it started being like, what? You were perfect doing this last week, but all of a sudden, it was like, nah, I'm not gonna put the effort in. And then looking at this usually means one thing. What do you think it means? Why do they do this? They want to save money, maybe? So many users, all of a sudden it became popular and it started costing them. It's also another signal of something else waiting behind the curve. Then we waited a week after, and then we saw the leak of Mythos. And apparently, it's insanely competent. You can never trust benchmark. Maybe the quote should say, all benchmarks are wrong, but some are useful, to paraphrase that again. But I think we only see the tip of this iceberg, and what innovative companies actually can accomplish now is start to be very close to applied research. And here I'm seeing Korea being very good in that space. So I think we can actually learn a lot from working together, because literally this is a space happening in front of us, and sometimes we aren't the best at working with uncertainty, and I developed this model to be able to talk about it, and we're going to see if animations works. So usually what happens is you have some sort of event over here. So let's say this is 2017, attention is all you need, and it's just been released. How many was excited? Probably the wrong crowd to ask about that, but I remember being very excited. So I told all my friends at Neo4j, what about this pre-trained transformer? We're doing graph neural networks. It's much cooler. I'm like, isn't this pretty much the same thing? I was kicked out, and then what happens, right? So with that said, the room for action decreases over time, right? So if we look over here, 2017, everybody could be a language lab. It was very easy. Over here, I wouldn't suggest to start one. You're way behind, right? So literally what we have is this idea of figuring out kind of what we need to take decisions. So what I unfortunately noticing in a research center state-owned is that it's very hard to take decision. We are very confident. We would like to have a lot of information before taking decisions. I think this is our struggle. This is where we need help. I'm asking you to help us. How can we be better together to actually take decisions, right? Because this is how we do. This is also in the commercial world, is the quarterly report. You build a system that solves the quarterly report, but it doesn't go for long vision. Research is long vision. Okay, maybe we need a new funding model. And then at the same time, we look at the startup community. It's literally uncertainty all the time. If you have worked in a startup, you would know this. It's very common. Do we have, if we don't get the funding next month, everybody is fired. There's 50 people on the payroll. This is a completely normal scenario. I mean, every single startup has this thing, which also attracts people that are slightly stupid and crazy in that sense, like me. So what we do is we need to figure out how to balance this, right? Because in the middle here, we have this art of knowing enough and the speed to act. So I think what we need to do is push established organization to actually be a little bit braver. And if we are to be braver, what better way to be brave and to do it with someone you like someone that can teach us something and have a good time together. So this is an open call for all Korean people. Come to Sweden, check out our Gigafactory when we got it, fingers crossed. I will show you my horrible Korean if you come. I can also teach you all about Sweden and all the beautiful things. And with that said, I would like to thank the Nexus team for having me and so on. So that's it for me. Thank you.
Thank you very much, Stephen. This is quite brilliantly engaging discussion and it's quite insightful. Do we have any questions? Oh, we do? Okay.
Thank you for the presentation. It's a little bit surprising to see how you were able to catch what unfolded after the upstage presentation in December. My question to you is whether EU states have the same kind of rigor or how should I put it, the intent for scrutiny when it comes to non-domestically raised or trained models. So say in the Korean, the dynamics that you watched here unfold, it's essentially that when you build models from scratch, you have to ensure that it didn't come from a Chinese. It can come from open source, but it should not come from an established Chinese model. And it's very clear to the Korean people because the money that is put into the foundational model project is Korean tax money.
Yeah.
And essentially for that reason, you cannot bring in an externally raised model or any kind of code that was written in for that model. But in the EU context, I wonder to what extent is sovereign. And in the Korean sort of discussion that is ongoing now, it seems that open source, if raised in Silicon Valley, it's allowed. But if elsewhere, then it's a question. And I'm normally based in Doha, in Qatar, and all the Gulf states, they have their sovereign, they call it sovereign, but they trained it with Arabic data, and all of the 6 countries of the GCC, they have the intent to raise their models to the extent that they level up to, I don't think they will, but they level up to OpenAI or Anthropic. And it doesn't make sense to me, but because the level of data they have is only limited to Arabic. But here, the data is also limited just to Korean. And I wonder if there is some similarity in this discussion in the EU context, because you have 27 languages. Sorry, is it 27 languages? 27 member states?
Or it's sometimes a drunk dialect if you compare Swedish and Dutch. So the number is good. We're not, so you're on par. No, I think you're onto something. And I think what stands out differently here is that the Korean language or a lot of the Asian language are very different from, let's say, English or Germanic languages, right? So you had to actually, you couldn't really reuse. And I remember talking about this three years ago with Twalsak at Upstage and how the English lab stopped publishing things all of a sudden. So it's like, okay, there's nothing published. So everybody in the community had to come together and start doing the research together. So I think that worked in your advantage almost. It was hard work, but then it set you up with a mind. So I would argue that you're actually ahead of that. I see the very similar conversations like, okay, we can use the OSS model or any open source model from the big players. But then I have governments, and they're like, I'm not sure. So we haven't really decided, I think, which is the honest answer. And that's also the reason why we partnered with Mistral in this case, which is the only AI lab which is having any sovereign ideas in Europe of scale. So with that, we did, for example, a very interesting project with Ericsson, the telco provider. So they have a lot of own languages, which is not coding languages, which is not publicly available. So in that case, we took their coding model and then we kind of reinforcement learning and post-trained it to work on those. So I think we are trying to figure it out. We don't have the answers. And then we sometimes also have this, especially Sweden, to be honest. So my time at AI Sweden, we decided that we wanted to do a Swedish model or a Northern Germanic model. So excluding Finland, that's sorry Finnish people. There aren't any, there's a different language category, so that's more towards Russia side. But Danish, Norwegian, and Swedish is almost like a drunk person. It's like, you know, sluttering in the face like that. So with that said, what we tried to do, we used OpenCrawl to crawl internet for, of course, all data. And then we have this consensus thing. We don't want to do the bad thing in Sweden very often. We try to be polite and ask for permission all the time. So we called out to every single company, hi, we crawled internet and we found data that probably should be copyrighted. Do you want us to remove it from the training data set? And then we have 25 lawsuits coming up immediately. So now we have been dealing with those lawsuits and have not been starting training the models. So I guess the answer is we're figuring it out as we go. And for me, I see a lot of things that I can learn from. But from the scrutiny thing, I think you're doing absolutely right. But again, seeing how that scrutiny was, first it felt very harsh. I'm like, oh, this is like drama, a scandal almost. But then everybody come together, they shared all the data openly, and everybody sat down on the table, and everybody participated to verify if it was true or not. And I think that was, I was like mind blown seeing it, honestly. I'm like, wow, this is good sports. So that's one thing that I want to bring back. Let's work together as a nation to fix this. So this is for me the inspiration. So sorry for the long answer, but it was a complicated question. But thank you.
Thank you. Sorry. May we take that for the coffee break? Thank you very much. Now we are. It's time for our first panel, but before that, one huge round of applause for Stefan. And I'm sure that the coffee break as well and lunch break, if Stefan is around, is going to be quite interesting. So please reach out to him. It is time for our first panel discussion of the day, which is focusing on the critical intersection of AI, cybersecurity, and supply chain resilience. So I will hand it over to our moderator, Kieran O'Riordan, Director of European Policy of Eclipse Foundation, and who is going to be joined by an esteemed panel of experts from the Presidential Council on National AI Strategy in the Republic of Korea, OSBC, and FOSS for All. While we still prepare the setting, do we want to add some slides? Is it very last minute necessary? Okay, but then we can, while we do that, I think we can set the stage as well, if it's just possible to have the chairs on the stage. And speaking of time, since we started a bit later, we will be cutting the coffee break for 10 minutes. Hope that is not too harsh of a punishment for you. And no matter when we finish the panels and the presentations, we will end the lunch break at 13:45, so the rest of the day remains unchanged. So I hope everyone is fine with that decision that we have made. So just to check if everything is okay with the slides.
Shall I begin while we're...
Absolutely, perfect. Thank you very much, Kieran.
Thank you very much. So I think everyone should be proud of the panel they create when they organize an event like this. So like everyone else, I have to say that this panel is the best panel of the day. We're going to talk about a variety of really important topics. One of the key things, of course, that is in every event and almost every presentation now is AI. And so we're going to discuss the topic of AI from 3 different perspectives. We're going to look at the community ecosystem, we're going to look at the academic ecosystem, and we're going to look at the business ecosystem. So the first half of the panel will be about mostly how the free and open source ecosystem is dealing with new issues created by AI. And so we'll discuss the problems, and then we'll also be able to discuss some ideas for solutions. Then at the end, if there is consensus that there is a lot of work and that these are really difficult problems to solve, then we will keep the last 15 minutes for a discussion of how we organize and how within our ecosystem, we can create networks and groups and experts to work on all these new topics. Alternatively, if we discuss AI for 30 minutes and then decide that it's actually really easy and not going to cause any problems, then we can just talk about baseball. So, so the cameraman has said that I should stay in the middle. As a former gymnast, I'm used to getting extra points for using the entire stage. So, so very quickly, I'd like to. The reason we're talking about policy is that one thing our ecosystem has to understand is that policy is the new licensing. For 40 years, we have worked on the legal framework, the legal foundation of our ecosystem through licenses and project policies, but now the majority of the regulation or the majority of the policy is coming from the governments. And so we have to show the governments that we are something that is a solution, we're not a problem, and that laws should support free and open source software. So the important areas at the moment are, of course, cybersecurity, international relations, and AI. We're still working on how to solve the issues of AI. One important topic we will talk about a lot this year is that there was always an issue of security, and people asked, how can open source be secure if everyone can read the code? But we might have had more people looking for exploits in our code, but we also had a stronger response because the entire community and ecosystem can work on responses. An interesting change now with AI is that AI can read software source code, but it can also read binaries. And so now free and open source software is no longer the one that can be read by everyone. All software can be read by everyone. And the difference is that we still have the advantage that we can form coalitions to work on solving these issues. Policy is complicated. And so we've formed an open regulatory compliance working group to work on these topics. I wanted to leave the rest of the time for our panel, and so during our panel we'll discuss the topics that I've just mentioned and possible ways to work with governments for how we will solve these. With that, if I could have my three panelists, I'd like to welcome you to the stage, and then, do we have 3 microphones? Okay. Yeah. Now. So there we are. So the first thing I'd like to do is I'd like to ask you to introduce yourselves. So actually, I'll sit in the end maybe. I'll sit here. And, so as I mentioned, we have 3 backgrounds. We have more of a developer focus, business focus, and academic focus. But if you'd like to briefly introduce your projects and what you have been working on.
Hello, I'm Sungjun Moon, or just Moon, from the Fospo. We're the organization by the free and open source communities to solve the problems of the communities, such as like legal problem, tax problem, or any fund problems, by providing some sponsorships, such as like fiscal sponsorships, or just like a real fund from the other places like the government or from ourselves. And yeah.
Hello, hi. Hi, I'm Taekwan Kim. I'm the CEO and president of OSBC, which provides open source governance and risk management consulting to most of the large companies, which in the upstream of a global supply chain of IT products, and then also software embedded products. Actually, I also served as the chairman of a Korea Open Source Association, which has more than 200 members of open source related businesses or open source using open source consuming actually the companies in Korea.
Good morning. I'm glad to be here. I'm Yoon Sung Choi, a member of a Presidential Council on National AI Strategy. Before we start the panel discussion, I want to say a little bit about our council and directions. As we navigate the era of agentic AI, we are witnessing a paradigm shift where software supply chains are not just technical backend, but the very foundation of national sovereignty. So from my experience in fostering Korea's white hat hacker ecosystem and designing national supply chain security guidelines, I have learned one lesson. Passive defense is no longer an option. So today I'm looking forward to discussing how we can turn software transparency and security by design requirements from regulatory burdens into safe paths for global innovation and collaboration.
So on that, to get that started, could we start with Sungjun? You are involved in the FFmpeg software project, and could you give us some experience you have with how AI has changed the development dynamic?
Sure. So I'm not FFmpeg developer, but I know some developers, and I've seen the things currently happening with some AI provided security report, especially from the Anthropic methods, like as mentioned at the previous presentation. Generally, it used to be really sloppy reports mostly. So it's more work than the actual. So it's really hard to review those kind of really long AI generated text, and it's very helpful. But it used to be like that. But I saw the actual patch that Anthropic sent to the FFmpeg, but it's like just 3 or 4 lines changes. I've seen that, but it wasn't like the previous AI report. But what I can say is, it feels like it's not fully generated by the AI. It's human was involved for that report. So I think that the Anthropic's model made several security problems findings. After that, some real security engineer found the actual vulnerability from some software and refined the report and sent to the FFmpeg. So there's no like silver bullet for the fixing the vulnerabilities of the softwares for now, I guess.
And take one, if I can also ask you a similar question on how you see the security being compromised or harmed by all these extra security vulnerabilities being found in software.
Right. I mean, actually, we are living in AI era, right? So AI changed the cybersecurity space dramatically for the last few months. Actually, 2 months ago, a Spanish software engineer called Semi actually used the AI code generator, Cloud Code, to develop, to actually find a vulnerability and develop exploits into the DJI's robot vacuum cleaners. He successfully managed it, using that exploit kit, he successfully managed to gain the control of 7,000 robot vacuum cleaners all over the world. So that was just the beginning. And then a couple of weeks ago, Anthropic shared the news that its AI model Mythos actually could discover new vulnerabilities which were not discovered for the last more than 20 years in the Berkeley BSD license, BSD Linux kernel. And then it successfully managed to develop exploits and then shared it with others. So actually Anthropic closed, they didn't want to offer Mythos to the public. And then after that, that was the sphere. These are the spheres of AI. But to defend from to defend that huge, the massive consortium was formed last week among Anthropic, Apple, Amazon, Microsoft, Linux Foundation, and NVIDIA as well. Also, a financial partner joined, which was like a JP Morgan, which is like a huge consortium to defend, from this kind of AI-generated, AI-powered attacks. So this is AI-powered, AI-derived defense activities. So we are now entering a new era. Traditional defense systems do not work, would not work. Because now actually AI can discover new vulnerabilities. And then it can generate exploits. And then it can automate the hackings with these exploits. So traditionally, the hacking actually happened like this. New vulnerability is discovered. That is, on that day is called the 0 day. And then from that day on, hackers develop exploit kits. And then they use those exploit kits to manually approach most of the servers which may use those vulnerable components in their servers or devices. But in the AI era, this kind of 0 day may not mean much, because AI can discover new vulnerabilities. And then also, even new vulnerabilities are found and then shared in the public. The hacking cycle, exploit cycle, became much reduced. So new statistics actually share the exploit using exploits using AI-generated exploit kits may happen even 27 seconds after the new vulnerability is discovered. So thanks to the CRA and other regulatory support, actually the SBOMs SBOMs are now becoming more popular and more pushed out and then enforced. But SBOMs are, in this era, SBOMs are not enough, not sufficient. We have to keep validating, keep monitoring, keep verifying these SBOMs, because SBOMs are static. So in the area, we may want to look at the CRA and then SBOMs again, and how to manage the SBOMs actually more efficient and more effective to defend these kind of AI-powered attacks.
It's interesting that we talk about 0 days, and now the exploits are being created in 27 seconds, and so maybe we need new terminology of 0 minute and 0 hour exploits. Professor Choi, could you also talk about how we can possibly turn the negatives into positives, and how we can also use AI, how AI can be a good thing for the security of open source?
Mythos preview, it huge impact for security industry. And yesterday I saw a report about the Mythos preview, and some of the experts is saying this is kind of a marketing, because they introduced more than 1,000 new vulnerabilities, but I heard that there is only 200 vulnerabilities verified. So I'm a little bit agree with Mr. Moon's perspective, but mainly I'm agree with Taekwon Kim's view, because the paradigm of attack has already shifted, because of the AI generate the source code. So we are saying it's vibe coding, right? So this new coding skill is accelerating development, and vulnerabilities are cascading proportionally, and adversaries uses AI agents to hunt for 0 days 24/7. So dependence can never win this war manually. So as I said, we need a new automated verification system, because we are using some other person's source code or binaries. That means untrusted dependency is affect my software or my system. So we must define, verify all the dependencies. The dependencies is now a big problem. AI brings new dependencies from not untrusted repositories. So this is the kind of one problem. And I guess our open source developers need to verify their code or binary by themselves, because AI doesn't make them clearly disclose also all the so-called or vulnerabilities. No, zero. So
I had a question on that topic for Sungjun, but do you have something you want to add first?
If I add just one more thing, since I talked about the different side of the things, but I want to talk about the thing I believe everyone would agree on here. So I believe that this kind of tools, AI tools or whatever, can provide the possibilities, but for now it gave some noises, but I believe it will be less noisy. But I think the most important thing is making the policy or law to make people to find the vulnerabilities legally. Sometimes it's illegal, or sometimes the companies, if I submit the security vulnerabilities, so for some company, really huge company in Korea, it's actual case, they ignored it and they sent the DMCA, they blocked the whole report by sending the DMCA. So I think the government and the company should be changed to the adopting the vulnerabilities from the communities, and they feel much less to provide the communities to feel free to send the patches to some closed or open source companies or whatever like that.
And so the question I wanted to ask you is about how do we ensure that AI is working for us and it's helping us? And so I wanted to get onto the SBOM question, but before I had a quick question for you about sovereign AI and national, regional AI. to generate this, it requires data, and we often have to try and obtain this from governments and from companies and public sources. Do you have any experience, or do you have any? Are there activities in South Korea where people are trying to generate AI models that could be useful to ensure we're not dependent on these models from other countries?
I wasn't making some like a sovereign AI model or something like that, but since it needs so that kind of sovereign AI needs a lot of data, so I tried to get some open data from the government like last month, but such open data isn't that open that much. So it's like opening a door with a small gap. It's technically open, but it's really hard to get in. So you need a registration number, or like a registered national, or registered in Korea as a foreigner to get the data, and then you need a phone number. It's okay, but it's for kind of safety and not abuse the things. But their way to provide the data is a little bit outdated. So their API is broken sometimes, like a lot. And their API documentation isn't provided well. Sometimes it's just a picture, so it's really hard to understand. Or if it's usually in Korean, so if you don't speak Korean well, it's really hard to get some data. But what I believe is government is currently providing really, really great data. They just need a little bit better policy or statistics.
It also sounds like the sort of thing an AI tool could help with in the near future. But with that, I wanted to also discuss the topic of SBOMs, because this is one part of the solution, or maybe a part of the solution. Would somebody like to start the discussion of how we can use SBOMs to verify that an AI is behaving correctly?
Yes, I mean, we should use AI to generate SBOMs, right? So, and then we should actually use AI to keep monitoring the SBOMs as well. Actually, the problem is that currently the vulnerability database, actually these tools refer to, used to be mostly NVD, National Vulnerability, published by and created and shared by U.S. government. But actually, now you have EU-VDB, EU Vulnerability Database, which is kind of a superset of NVD. But actually, EU-DB should not be alone. So, because Korea, Japan, Asian companies are in the upstream of a global supply chain of all the IT or software embedded products. So we should collaborate on building EU-DB together, right? Not just by EU-based companies, but also by like all the Asian companies and other companies which are participating in the global supply chain of software or software embedded products. So and then if we did that, we can have like a much richer vulnerability database, globally shared, using AI tools to discover new vulnerabilities, and then update the vulnerability database with AI like a discovered vulnerability and so forth globally, not just by EU.
Professor?
Yeah. I deeply agree with Taekwon's talk. To summarize my point from a national security perspective, true digital sovereignty does not mean isolation, just like he said. We don't build every piece of software domestically. So in our highly independent global supply chain, sovereignty means the verifiable, controllable, the third-party code we rely on. That is why regulation like AI bombs, AIS bombs, or the EU CRA must not become mere trade barriers. They must serve as safe paths for EU, also Korea. So the mechanism to mathematically prove the transparency of our models, AI models, and so they can securely connect it to the global supply chain. I think this is the AI and SBOM's future.
I think that's a really important point. Yep.
One more thing. As I mentioned before, current SBOMs are static and self-declared. So we may need to embed the practice to keep monitoring and keep verifying those SBOMs, up to date. So in this CRA, actually, because CRA has a huge influence in global supply chain, including Koreans, Japanese, and other Asian countries. So maybe we should think about embedding a verification process in the practice of CRA, and then which can actually expedite the verification of SBOMs up to date using AI tools and so forth.
Yeah, I think it's really interesting that a lot of these topics, they can be discussed without mentioning free and open source software, but the approach is the same approach that we always used in free and open source software. And so I think that the problems of AI models, which are they're different to software, but the same type of thinking is needed to try and solve these problems through transparency and through everyone being in control of their copy. But getting early access to new powerful models is very important, but it also could create a dependency then on these models if only one company has access to the models. If anyone has a solution or comments on that, I'd be happy to hear them. But what do you think of the current the initiative Glasswing, which is discussed a lot in the press? Is that being discussed by South Korean companies as well, or would it be an issue if access was only for companies in other countries? Maybe this touches on then the idea of data transparency and how do we know what data is being used to train these models? Do you think there's any solution based on data transparency and maybe, or is it more important that we have access to computing power? Should governments provide access to data centers as a way to allow companies to use these AI models?
This new powerful model implies they are saying like they will use this powerful model within some companies, like he said, and this is I think this is the problem. Big problem for the rest of the world or other companies. So in Korea, we have a new project to build our foundational model by ourselves, and we will try to make or train about the cybersecurity data to our sovereign model, and this is a part of plan now, so maybe we can have a Mrs. preview, like new model by ourselves, but the capability will be different. But good thing is not like Misa's preview, more less power model can find the open source vulnerabilities. So we need to move on to that stage. And yes, this is our plan now. So we are preparing.
And
actually, we have some government-funded sovereign AI projects. I think they're selecting the consortiums. They've selected three companies consortium. Actually, they want to build that based on open source AI model because it is not very easy to develop the model from scratch. So we may want to use open source based AI models and then to develop sovereign AI.
yeah, and if we can organize collaboration between Europe and South Korea and other countries, then that would hopefully give us the capacity and the size necessary to be able to develop a really useful model. In the European Union, we have the AI Act, which is still slowly coming into force. There's also AI legislation in South Korea, and I think in the future there will be more. Can you talk about any of the current situation, or whether AI regulation is being done correctly, or if it's going to just create more problems?
Yes, we have AI basic law. It's similar to EU's AI Act, but our focusing is on promoting our AI industry. So there is the main different thing is in AI Act in EU, they are start from the risk management, right? But we are regulating only highly risked AI models. So it's a little bit different. EU's AI Act is more general.
And Taekwon, if I can ask you about the business ecosystem in South Korea, I think you're familiar with small and medium businesses as well. Do you think that there is a dependency among businesses on AI services, and are businesses now dependent on, in particular, foreign AI services? Is this a problem that needs to be solved?
Yeah, right. I mean, small and medium companies now began to heavily depend on AI coding services and so forth. Also, for example, in my experience, actually, for the past 6-8 months, we use the AI services heavily. So now I think how could I live without AI, right? So, I mean, also small and medium companies start to, interestingly, large companies are slow to adopt AI coding services because they have their own policies and compliance issues and so forth. But actually, small and medium companies are very much, mostly less, they don't have enough resources, right? So they are always less hired. So less. They are not sufficient of the coding people and so forth. So human resources. So they actually started heavily depend on AI services such as AI code generators or just ChatGPT, Gemini, and Perplex, and those AI the AI advice services. Either an individual license or or like an enterprise license through. But actually the problem is, I mean, for example, Samsung prohibited using ChatGPT within their company because of because they are worried about leaking their internal information to the by uploading those information onto the ChatGPT, or similar like commercial closed AI services. So they are developing their own AI systems based on their requirements from the company. So most of companies are looking at their own like AI models because they do not want to upload the highly sensitive company information onto the AI servers, AI clouds or AI services, which are provided by potential competitor of the companies.
Can I add more?
Mm-hmm.
Small medium enterprises is the weakest link in the software supply chain security. So attackers usually try to find the weakest link as their the attack gate. So open source democratizes security costs that no single company can bear alone. In the Cloud-Edge Continuum, where countless third-party components are interwoven, so trust is impossible without transparency. And I propose this. Korea-EU cooperation must go beyond the simply unifying compliance paperwork. We must build a joint resilience corridor, a live ecosystem where our open source communities and government agencies share threat intelligence in real time and jointly remediate vulnerability at machine speed. That means we need to bring our security technologies into the software developers environment. It means in the CI/CD or DevOps.
That's interesting. So it's like using the open source approach, but instead of looking from the developers, you're looking from the users, and ensuring that the users have some way to verify the behavior of the AI model. And so maybe this is something that we need to solve through national laws and international cooperation, but it can be inspired by the approach of the free and open source ecosystem. Sungjun, so we're discussing companies up until now, but can you also talk about from project perspectives, do you see that there's pressure to use AI contributions? I think in a lot of free and open source packages, people would like to just ban AI contributions. That's the easiest approach, but then you also lose a lot of positive code if you take that approach. Is this a conflict or a discussion within FFmpeg?
In the case of the FFmpeg, I have like only few knowledges, but I can talk about the other side. So I think the best part of one of the best part of the free and open source community is each community is different. So each community follows a different policy. But if I talk about the really recent AI policy from the Linux kernel, they just released the 7.0 kernel like 2 days ago or a day ago, and they also included the AI policy of the if you want to use, how should use it, like what AI model did you use and which model like versions and how you used and did you review it right. So they made a guideline to use the AI. I think it's very progressive way to let people to use the AI, not just blocking everything. But for the Gen 2 Linux distribution, they currently block every AI-generated contributions for now, but I think it can be changed. But as I told you, each community is different. But the problem is actually the biggest problem I've seen from the AI-generated like contributions is not from the like non-profit or just random open source project. It's mostly from the company who work on the open source project. So they usually provide the bounties. So if you make some contributions, you can get money. Since the like AI models are getting better, so people are becoming more like gold digger. So if when they release the bounty, they just use their whole tokens to get the bounties and send the random patches, and the reviewers and the maintainers are very stressed about that. But usually the bounties are from the companies. I think it's their policy should be changed. It's not because of the users who use the AI. Because it's more like they let them to do that. So they should change the policy to make people to use the AI in much right way.
So before we move on to the last section to talk about organizing and how we collaborate and cooperate and coordinate, do any of the three of you have any final points that you think the audience would like to hear about on the topic of AI solutions to challenges?
Actually, interestingly, I mean, Korea is very fast in adopting, as I mentioned before, adopting AI services. One of the reasons is actually the labor law of Korea. For small and medium companies, if they hire people, they cannot fire them easily. They cannot even lay them off, even though they are losing money. So instead of hiring new people, if they are understaffed, instead of hiring new people, they just start to use AI services. So this is kind of a controversy. So maybe we should think about how to, use AI, more human friendly, right? So that it doesn't actually block hiring new people, creating new jobs.
From my perspective, as a policymaker, I believe we cannot simply place the burden on the community's goodwill. So even if maintainers want to comply enthusiastically, it is impossible without the burden and manpower to adopt automated tools. That is exactly why Korean government is preparing maturity-based policies such as vouchers and shared scanning platforms. So we aim to provide the CI/CD automated security infrastructure for free, so that your excellent vision can actually become a reality, like you mentioned in the last presentation. And furthermore, the mutual recognition is exactly the essence of what I called a safe path, and a pipeline where AI bomb mechanically verified in Korea is automatically accepted in Europe, So this is only way to prevent global fragmentation, I guess. And must be technically supported by a resilience corridor, where both our open source communities share threat intelligence 24/7 in real time.
The topic of mutual recognition is extremely important. There can be entire conferences on that topic, and I think it is really important that we avoid the situation where we have different regulations in each country, and then if a project or a company wants to be active on a global scale, they have to try and understand and comply with regulations for every different country. And so, but this is one of the reasons why we have to cooperate, and that's one of the reasons why I'm in South Korea and why we're trying to build connections through this Nexus Forum as well. And so that brings me on to the final topic, the question of collaboration and organizing ourselves. In some ways it's more difficult or more complex for the free and open source ecosystem, because we're not a single company with a single leader and a structure and a set of policies. We are a large collection of companies, and we are volunteers, and we are academics, and we have all these different people who have different levels of finance and different interests, and so it's essential to work together, and this takes a lot of communication then. And so I met all three of you through various events that you were organizing, and this is something that I was quite impressed by, and I think this is what we need more of, so that we can have this international cooperation. And so for the final few minutes, I wanted to ask you to discuss the events and the groups that you have been organizing and working on, and if you have any thoughts on how we can improve cooperation between the EU and South Korea, I'd be very interested. Should we start, Sungjun?
First of all, I'm really thank you for letting me be here, and I believe that you guys might notice it. I'm wearing the hoodies from the FOSDEM. It's the biggest open source conference in the world, organizing in the Belgium, Brussels every year, first week of the February, first weekend of the February. What I learned from the collaborating with the others, I started with collaborating people mostly from the other countries. So what I learned is, especially in Europe, they've been collaborating each other really in good way, like they're solving some problems of the free and open source softwares and the communities. So what I saw at those kind of people is, I really want such a thing in Korea. So I met some people in Korea who is working on the open source communities or a project to make it happen. Also, it happens in Korea too. So that's why I started. And other people started the non-profit organization called FOSFO to help others and solve the problems other communities, eventually making the sustainable ecosystem, free and open source ecosystem in Korea. But it cannot be done by ourselves. So that's why we always collaborate with the other people from other countries, and especially from the Europe, EU, because they've been always doing it for over 30 years. So I wish to keep collaborate with others and meet more new people to find more possibilities and hang out with others.
COSA, Korea Open Source Software Association, where I served as chairman for 2 years until February this year, has been holding regular open source conferences in Korea. We call it K Open Source Conference. I would like you to participate, if you can. Also, Linux Foundation's Open Source Summit started to be held from last year. So I think it will continue to hold in Korea as well from now on. And then OSBC, my company, has been holding OSBC Open Source Conference for the last 16 years. This is the 15th year, which actually focuses on open source governance and risks. And then this conference has been renamed as Open Source and AI Conference, from this year. It will be held on June 11th. Actually, I invited Kieran to speak on behalf of EU community. Also speakers from Sony, Samsung, LG AI, and all those people actually will participate to speak. This is an invitation-only event, so if you like to join, please give me a message, and then I will send you the invitation. About 200 people will mostly attend, but this is like a free event, so you can actually attend freely if you like. Just let me know, I will send you the invitation. Actually, last year, since you are from EU, my friend Ibrahim Hada, that Volvo actually spoke about Volvo's S-BOM practice. So this year, we'll talk about some more practices about of Samsung, Sony, and all those, which are in the upstream of the global supply chain. All right, thank you.
Because I'm also in the university, so and I think AI S-BOM is in the R&D stage. And last year, I proposed a national R&D project to our government for new AI BOM platform, but it couldn't be started because of the budget issue. But when I posted this R&D idea to internationally, there was 8 applicants from Germany. Actually, the most famous German research institute, they applied more than 6 teams, and also there was an AI research center. So maybe I can make this international joint R&D project for the next year again. This could be a one cooperation. And I'm in Presidential Council on National AI Strategy. So in that committee, there is a global cooperation working group. So if you want to, or if you have any idea to cooperation with our government about AI, so you can contact me, so I can introduce their action or their tasks.
I'd like to sincerely thank the three of you for the work you do. I think it's extremely important that we not just do our own work, but also help others to get involved and help people to collaborate, because working on these huge problems on your own is just impossible. So thank you very much for the work you do. For me, this is my 3rd time in South Korea. I will be back again and again. I've decided that for me, EU cooperation with South Korea is important, and for that reason, 저는 한국어로 공부하고 있어요. And I will hopefully one day be able to actually do a presentation in Korean, but today is not that day. A sincere thank you to all three. Please, if you are interested in these topics, these are 3 of the most important people in South Korea to be in contact with, to be involved in the massive collaborative work that we have to do to define policy and to work on all these issues of open technologies. Thank you very much.
Thank you very much. This was quite insightful, so thank you, Yoon Song, Taekwon, and Songjun for participating, and also to Kieran for brilliantly moderating the session. Since we are a bit behind the schedule and we would like to continue the day properly, we will be cutting a bit the coffee break. So the coffee break is just outside, and please return to your seats at in 15 minutes. So this is going to be at 11:48. So we dive into the cybersecurity priorities of this event. So thank you very much. See you in 15 minutes. welcome back, and thank you for being so brief with the coffee. We will for sure have a bit longer lunch. But now it is time to our next session, which examines the priorities within the EU ecosystem regarding cybersecurity. To guide us through this, please, well, he's already on the stage, but please welcome with an applause, Iraklis Simeonidis, Senior Researcher at RISE. So also Iraklis will have a fireside chat or an interview that follows after this. So please, the stage is all yours.
Hello, everyone. Okay, thank you. Thank you very much for all the Koreans and EU people who are here. And what we're going to be talking a little bit about cybersecurity. It's actually a team effort from the working group that I've been like helping, supervise, kind of like, yeah, leading the discussions. So we needed to provide an input, right, for the roadmap. And I was listening to the morning's discussions. Thomas, for example, Thomas, and Professor Young-Suk. I hope you pronounce your name. So usually when we are talking about the security people, we are kind of like the mom in the room, I would say. It's like, okay, guys, you want to go and play, you want to do your stuff, like take your sweater with you. So this is like a Greek saying, and I guess like other cultures have the same. But please be aware, there are threats that you need to consider when you're deploying a system like an AI. And now we're talking about this huge thing. It's not only AI, it's Cloud-Edge-IoT, Continuum. Wow, like, okay, bombastic, too many things. So what we try to do in a nutshell is to summarize what are the priorities, what things need to be considered from EU and maybe Korea as well as priorities. And what I will be quickly talking about is, I guess this is a pointer, trusted infrastructure, AI, and federation. And essentially we have a few issues here. It's about the threat landscape, that are too many devices, too scattered, and too diverse. We have HPCs, we have personal devices, we have IoTs who are resource constrained. So we need to come with a 15-year progression recommendations over some three strategic priorities. So EU has some strengths, and is about this fundamental science, regulatory frameworks, privacy by design consciousness, trust, and interoperability, how things can operate, but also like huge dependency on hardware, for example, reactive perimeter on security, and the people who are involved in the working groups who are more into the SME world, they say also SME exclusion. So I'm a researcher, some things are, yeah, kind of like good that we have other people on board. And if I can make a little bit of this, like, where are we talking about? What are we talking about? Which like Lego bricks are we talking about we should be looking at? Hardware, security. Software, security. We heard just on the panel before about SBOM. Application, orchestration, data, network, and then cross layers, about automation, security, dynamic risk assessment, interoperability, security mechanisms, and a new term, I would say, which is compliance by design. EU is good at it, like creating regulatory frameworks, but how you can put it into real world to make it use of. So quickly, we identified like three main priorities, which are sovereign trust infrastructure. What does it mean? It means that it should include hardware, software, and and the data, the network. Now we are living in the era of AI. So cognitive, how can we protect the systems? How can we protect this whole infrastructure with AI for threats like APTs, advanced persistent threats? And how can we orchestrate all these things? How can you federate? So there, this vision is about three phases. And it took us a bit of time to go back and forth to sharpen this a little bit. And we thought of it as, because this is a little bit fluid, like, okay, you can say near term, mid term, long term, but what does it mean? You can put some dates, but you can put some years, but we thought of it like it could be interesting to see now we try to implement and set the foundations and try to advance the TRL, right? The readiness level of its era, focus point. Like for hardware, RISC-V, for example, for post-quantum, for interoperability, and then scale up. Once you establish the processes, try to scale up, and then an ambitious is to create an autonomy as much as with human in the loop, but very autonomous. And another thing that I would say EU leadership. So we have seen that EU with their standardizations and regulatory frameworks has been inspiring other countries with its DPR, right? So California Act, India is trying to do the same. So there is making it right or trying to make it right. It could be also inspiring others. And for each of these phases, where we should be looking at, what should we be looking at? It's about research and innovation, policy, operations, and market. So to advance on these four directions. And I'm not gonna, I'll just wrap up quickly. I mean, I'm not gonna put too much into detail, but we identified that, for example, in trusted infrastructure, we should be looking at PQC migration, like making the process when this quantum era knocks the door, that it's here, that we have processes to security by design. Hardware root of trust. So how can we, now the setup is we are completely dependent on hardware that is difficult to, I mean, not like manufactured or designed in Europe or other kind of, countries of, we can have a control, but at the same time, how can we, when in a hardware stack, how can we know that the hardware that we have there, they don't have any backdoor? They're not leaking information. And have a regulatory framework for that, like NIS2, Cyber Resilience Act, AI Act, creating pilots and slowly start testing in isolated environments and then create clusters, for example, energy, telco, and create an ecosystem around it. And apparently the market is to have an autonomy. The second point of priority is about the AI. So as it is in the first phase siloed, like to have this AI system and to have the processes of being trustworthy. So put AI in the loop, but know what we're doing, right? And then slowly try to, as we're scaling up, try to create an ecosystem around, try to create a perimeter or monitoring system where contains more and more federated environment, where at the end you can create an AA immune system swarm-based. And of course, you have also regulatory frameworks to support this. And the last one is federation. So these phases and priorities are intertwined. And here what it says is like creating, like, okay, you want to create an ecosystem that these things are talking with each other. How can we do it? From the data points to the protocols to the architecture. So how can you create an ecosystem with policies, standards, regulatory frameworks, support also the market? How can you do it? So we identified some of the areas, focus areas that we should be prioritizing at. So this is kind of a wrap up, I would say. The aim is to accelerate a sovereign secure silicon, PQC migration, and NISA is looking at. We know that NIST is the one who is leading, but EU should be also looking at this and doing their own homework. And then NISA is actually have some guidelines out, but slowly to put it into the processes of migration, like putting on the systems and testing. Interoperability. I don't know if there are people from data spaces. EU is trying a lot to do with data. We heard about data and APIs and broken APIs. EU is trying to put this interoperability of data spaces to share the data and testing AI algorithms. So how can we create secure interoperability ecosystems, protocols, procedures, crypto in place, anything on all stacks. Continuous certification is another interesting thing. You need someone to check that what you do is like claiming that is correct, right? So they need the processes of testing. And then federation, if you want to do cross-border, Korea, this one country, however, we know for our environment that we have like an ecosystem of different, we have an umbrella, but at the same time, every nation might have their own way of doing things. So how can we create a cross-border security operations center, for example, SOC stands for. And then SMEs, in a way to help them on this ecosystem. And this is me, but it wouldn't be possible if other team. So it's a team effort from the working group team of the working group of cybersecurity. So thanks to them, they're not here. And there are more people. Yeah, just try to do a screenshot of as many as I could. And with that said, yeah, that was a brief wrap up of our work that we have done. And thanks a lot. I hope, yeah, maybe I was quick, right? So any question that you have? No questions? Awesome. So we are the mom in the room, just for you to know. So we're going to be chasing you with your sweaters to bring it. So, and that said, we're going to the next, is it a panel? Ian, it's a chat. I don't know. If we, so first, thank you. Thank you for your attention. Thank you very much. It's been great to be here. And wait, I'm doing something wrong. You are the master, so please. Yes, okay.
If you haven't had enough of rice by now, you will totally be after this one. So third rice presentation of the day.
Okay, so part of, okay, yeah. Part of the discussion, so of a little bit of the technical touch, a little bit of the technical flavor, but also understanding where we're heading and sharing knowledge. It's about telco. And I think our, so Ian is here, and Dr. Taisik Chewong, I think, I don't know if, but we can proceed. As we, so a little bit about Ian. He's a senior researcher on AI, edge systems, data quality, sensor fusion. Works on low latency networks, explainable AI, telco cloud, and EU research initiatives. Is it correct, all this, or
yes.
Did I miss something? Awesome.
No, it's correct.
Okay, cool. And my name is Iraklis Miornidis. I'm a senior research scientist. I'm working on secure architectures. I have a PhD in applied crypto, and yeah, I'm here with you today. And first, I want to say thank you. It's nice to be here, and I'm going to read it in English. So, Gamsham Hamida, Igos e Oge, Doseo, Kipe Nida. Okay, she's laughing. Probably something is wrong, something is right, and something is, somehow along these lines it should be. Thank you very much. Thank you. So, Ian, please take a seat. Or not, we won't stand?
No, I can sit down.
Okay. So, 5G, 6G, and we're moving towards, right? And probably there are some misconceptions or understanding that 6G actually is not only about connectivity. So what is it about? What's the biggest misconception? Yep.
Yeah, thank you for inviting me. So just briefly, I've been working with telecom for almost 30 years. I actually moved to Sweden, not for love, marriage, or money, but to work with our dear friends Ericsson. I don't know what I did in the past life to deserve that, but anyways, I'm paying it for this one. But yeah, so probably the biggest misconception, I hope people know what 6G is. If you don't, just look confused. But I mean, you do, just say I don't know what it is, and I can start even more further back. But what you'll see as a customer is a faster internet. However, there's a lot more than that. And one important thing about 5G, well, 1, 2, 3, 4, 2, 3, 4, 5, 6G, there's always a huge step forward. Some people will say that there are bigger steps in the odd numbers, sort of 3 to 5 and, oh, sorry, so 2 to 3 and 4 to 5 and 5 to 6. So you will hear this. But as a consumer, you'll see a faster internet. But underneath, there's huge changes. And we've heard a lot about it in these 2 days, AI, intelligence, physical AI. You hear this a lot from the Korean partners, physical AI. And that's something that 6G is trying to embrace. Let me just say one thing about, I know you've done a really good job about the questions, but there's one thing that I kind of need to say is,
please, yeah.
That is, new generations of telecom networks are not only at the behest of the consumer and download speeds, they're also at the operators. Because the operators don't want to just buy stuff from Samsung, Ericsson, and Nokia. So oddly enough, from Europe, I mean, from Sweden, from Korea and Sweden, we have 2 of the largest OEMs in the world, right? Which is pretty important, right, for our collaboration. But the operators, each time, would like to see new innovations so new actors can get in, right? Because they don't just want to buy the stuff from Samsung and Ericsson, right? It's an opportunity for them. So don't forget, it's not only technology, there's kind of a financial incentive. And who are the biggest customers of OEMs? It's the operators, right? So just to answer your question, that's a small diversion, and we might come back to it. But of course, we'll see faster internet. Of course, there'll be new technology in the network. You've already got the intelligence in your phone, but is the intelligence in the network? Well, I think they're working on that. I can see some nods there. But there's going to be a lot more, let me say, under the covers.
Okay, so is that as well about intelligence somehow on infrastructure, not for the infrastructure itself, or maybe for the infrastructure itself, that they will be giving services to operators? Yeah, maybe, what would you say about that?
I'm going to say this a lot because I always need a bit of time to think. That's a really good question. You hear a lot in EU projects about use cases. Oh, our use case is going to be remote surgery. A use case is going to be automated driving. You don't need that if you're a telecom operator because the use case is your own network. These are extremely complex entities. Remember, they're supporting legacy from 2G.
Okay.
If you look at there's nobody from Germany here, so I can give them some. I mean, they have these old networks, right? Upgrading is difficult. In many systems, you still have SMS messages. If you've got a wireless camera, it's sending out these messages. Oh, I'm still here. Your subscription is cancelled, but this thing is still sending out messages. So what I'm trying to say is, legacy networks, 2G, 3G, 4G, and 5G, is a big problem if you're providing equipment. And basically, these things break. If we get time, we can go back into that, but we shouldn't do now. So what I'm trying to say is, they would like intelligence to fix their own networks. They're not broken per se, down for days, but there are tickets. If anyone knows about software, we heard about open source, this idea of a ticket. Something is broken, right? Something, a dual SIM card in Singapore doesn't work. The telecom manufacturers and the software suppliers are constantly fixing these. So just to answer your question, that was a small kind of roundabout, and I'll try to do that to fill out the time. But the network is the use case.
The network is the use case and the services that they provide.
Yes.
So on the current landscape, we are from EU, right? What do you think there should be priorities for? Or should they be different? The EU should be doing differently? Or from the, I don't know, technical matters or non-technical as well?
Yeah, I was going to say that's a good question. They're all good questions because you've prepared meticulously. Absolutely. So just to go back to why they're doing 6G, is 5G, by the way, was supposed to be a business type leap. Everybody has cellular phones, but industry still doesn't have SIM cards or cellular access in a lot of their industries. I mean, we're talking about massive industries in Korea and Sweden, right? I mean, Electrolux, Scania, Hennes & Moritz, all these companies which have a lot of physical infrastructure, the same in Korea, shipbuilding, manufacturing. Really, the telecom network is not inside their daily operations, inside their machines, inside their whatever, little robot guy. And this was what 5G was trying to achieve, but it kind of failed in this respect. Right? But what 6G is going to do, and we might come back to that, I keep saying that as well, is it's really trying to get into the business segment. We might come back to integrated sensing and communication, but just skip that for a moment. So does the EU and Korea have the priorities right? Absolutely. But where it's pressing is the business case, not in the consumer case.
So, so maybe you mean about this private 5G, 6G, so that to change the Wi-Fi, let's say, and then to have these private networks that 6G and 5G should be supporting, but I guess 6G as well. So I would like to, but I don't know, ask about the floor, about Korean priorities on the telco. Do we have anyone that would like to comment? Have anyone from the telco?
Anybody know somebody at Samsung? I guess not.
Okay, so we can move on. So, Ian, we are coming from the world of research, right? Where do you think that there are most promising directions? Would that be on bringing AI on the services, on the networks, on the edge? What do you think is?
Yeah, good. I almost said it again. So this, what I talked about network intelligence, I'm going to stand up because I'm going to try to do a little demo of me. So this network intelligence, debugging their own system, use case, the network is the use case, it's fine, right? But what about the consumer? And one of the largest, or one of the potentially largest game changers in 6G is using the network to sense. So when you hear 6G in the future, you may hear this term, integrated sensing and communication, joint sensing and communication. If you hear that, what it means is they're using the network to sense. So if you've got a base station there and a base station there, it can simply do triangulation or distance to say, I'm here. So what does that mean? It means the network can sense where all the objects are. That was like that chair, for example. That was a good example where I would need a 6G to stop me being so clumsy. But what they're trying to do is say, well, we'll use the network to sense the environment, to sense the room, to sense people crashing into objects. This is brand new. It's been tried and tried and tried. However, the frequencies in the 5G were too low. So to say that Ian is there, Iraklis is here, we need much higher frequencies. And you'll hear that as well, terahertz communication. You're thinking, Jesus Christ, what does it mean, terahertz communication, joint sensing integration? Integrated sense and joint. It means the network knows where I am, which sort of makes sense, right? And then I was going to use a German word, plötzlich, then suddenly you've got exactly this industry that they wanted, right? If the industry can say, this device is there, this clumsy guy is there, are they going to collide? Are they going to move? Are there obstacles on train tracks? They've got finally what they wanted, if it works. Now, for people who know a little bit about radio frequencies, it's a tricky problem. But not only can you sense the environment, you can also sense the speed. So if this stuff works that they're promising, and there's a lot of EU projects promising this, I would take, if you're evaluating EU projects or Korean projects, really pin them down. How is this integrated sensing and joint sensing going to work? Coming back to your question, this potentially is really the game changer.
Okay. Good, nice. And I would say, what are your hopes for 6G? What?
Well, you asked me in the Google Docs, and I put a lot of future projects for RISE. No, I think there is still work to be done on the network intelligence. So for the people who do sort of root cause analysis, complex systems, I think we heard about them yesterday. There's potential there still to use AI to understand the telecom network. The thing is that the operators and the OEMs sort of know what they're doing. They know their software. We heard about it in the previous session, which I think was quite interesting. But they don't know what the crazy customers are doing, right? I mean, what the hell are they doing? Do you remember when you're not allowed to use your mobile phone on the plane? I don't know if people actually know why you're not allowed to do that. And one of the reasons is the plane was going so fast. The plane was going through areas on the cellular network which causing it to break. It didn't expect someone to be going 1,000 kilometers an hour. So that is sort of from the operator side. From the consumer side, if this integrated sensing and communication takes off, there are very clever people with AI and signal processing backgrounds. We're doing a little bit in there in automated driving. That would be great. It would be a game changer. The networks, certainly you don't need any kind of perception. I mean, you can still argue you need a camera, a LiDAR, whatever. But the network sort of knows what you're doing. Now, I would be a little bit scared if I was thinking, oh my God, what is he saying? The network knows I'm going to go and cheat him. I'm going to go and rob a bank or something. It's not like this. What you see is an image, it's not an image like a camera image, it's like a point cloud. If people have seen a LiDAR point cloud, it's like dots. If anything, this makes privacy better than cameras, where you can see people's faces and number plates. You can see the object, but you don't see any of the details which could reveal anything about them. So, just to answer your question, on the network intelligence side, there's plenty to do there, and on the application side, there is a lot to do. And I promise you, I'm already reviewing applications for something called Celtic Next in Europe. People are promising Pandora's box.
Yeah. Okay, questions from the audience? Do you have any for us? And
you know everything about 6G now, and what to watch out for when you read what people say.
So with that, maybe we wrap it up here. Thank you very much, Ian.
Thank you.
And to everyone. Yep, that's all.
Thank you very much to both Iraklis and Ian. That was quite nice fireside chat. Now it's time for our lunch break. So I think we are quite on time. So we will be back here in this auditorium at 13:45. So I wish everyone to have a pleasant lunch. So after this, we will be having other panels and a pitching session and closing remarks. So I think our partners from the university, we just need to follow them. For the ones that have not been here yesterday, I believe that the lunch is at the same place. So thank you very much for, let's say, the first part of the day, and see you very soon. So welcome back from lunch. I hope that you have enjoyed the food and the talks and the sun and the nice terrace that we have been taken to. There was some food that's been left, so if somebody wants to bring it home or if we can give it to other students, that would be really nice. So we take care of sustainability and zero waste. Now, after lunch, this is one of my favorite sessions, are always after lunch, because everybody is so full and attentive. We will begin this afternoon session by looking towards the quantum horizon. So to discuss building a joint quantum ecosystem, some best practices and some insights, please welcome to the stage Eneko Saba. He is a principal researcher at Technalia.
Hi, thank you for the presentation, Daniel. So today I would talk about quantum computing, but from a different angle, okay? This is not going to be a technical talk. I'm not going to talk about qubits, about entanglement. No, I'm going to talk about how to build an ecosystem around quantum computing, or maybe most important, why it is necessary to build a quantum ecosystem, okay? So, but first, let me talk, I think that you know about Technalia, but let me talk about Technalia and the group in which I am working. As you know, Technalia is a very big private research center in Spain. We are more or less 1,500 people. But of course, not all these people is working in the same thing. There's a wider or bigger area called digital transformation, in which we work in different kind of technologies, such as artificial intelligence, cybersecurity, computer vision, and quantum computing and quantum sensing. Okay, indeed, Juncal, that you know Juncal and me, we are part of the digital department, but we are not in the same group, because I am in the quantum computing and quantum sensing group, okay? So, one of the, and it has quite sense talking about quantum computing because it's a low TRL technology at this moment, Technalia. We are like a middleware between the university and the companies. We are a research center in which we have different kind of projects. Some projects are public funded and with a low TRL, so we work with universities. And we have higher TRL projects in which we work with companies trying, for example, to develop use cases or more applied projects, okay? So we usually are in the middle between the academia and the companies. And as I said, we are, talking about quantum computing is a quite big team. We are more than the ones that you can see here. We are more or less 25, 30 people. Of course, not all of us are working in the same topic, because within quantum computing, within quantum technologies, there are different fields, which such as quantum sensing, quantum optimization, quantum machine learning. So we all work in all this wide area, which is quantum technologies. Okay. So why quantum computing needs an ecosystem? Okay. One of the most important aspects is that quantum computing is different from most digital technologies that we are used to, okay? It's a highly complex topic in terms of technical perspective, and it requires very specialized people, very specialist talent, okay? And development cycles usually are long and with no, there's a lot of uncertainty, okay? So, at the same time, investment costs are high and the returns are not immediate. Why? Because of the same reason that I talked yesterday. The computers are not as mature as we want to be, and they are very expensive to build. So we need a lot of money and time, something that usually is contradictory. Because of the reason, there's no single actor. It doesn't matter if it's a startup, university, or a very large company, there's not a single actor that can realistically succeed alone. For example, think in IBM. IBM is one of the biggest computer builders, quantum computer builders in the world. So even IBM needs other people, okay? IBM needs, well, IBM, sorry, IBM is the Spanish pronunciation. IBM is needs, for example, scientists to use their computers. For example, IBM needs industry to put on the table the use cases that are going to be solved with their computers. So quantum computing force collaboration, okay? So what is a quantum ecosystem? When we talk about quantum ecosystem, we are not just talking about many organizations working together, okay? We need a structured interaction between many different actors. We need academia that generates knowledge. We need the infrastructure to access the hardware, okay? We need the industry to put the real problems, the data, for example, and we also need public institutions. Why? Public institutions to create programs for making projects. Because in our case, most of the projects, all the projects that we have, instead of 1 or 2, are public funded projects because the low TRL of the technology. So an ecosystem, a quantum ecosystem, only works if all these elements are connected, okay? Because a quantum ecosystem is not a sum of people, organizations, is indeed a system, okay? So, which are the key building blocks? There are different blocks in a quantum ecosystem that need to work together. First, scientific excellence, because it's a very theoretical topic with quantum computing, quantum mechanics. So we need strong fundamentals. So for this reason, we need scientific excellence. We need a shared infrastructure because quantum computers are very expensive. So it is not easy. It is very, very, very difficult, almost impossible for an institution to have a quantum computer in their premises. So we need, for example, in our case, Tecnalia. Tecnalia is a very big company, more than 1,500 people, but we cannot buy a quantum computer. We cannot make this bet, you know, because we have many other investments. We cannot invest in a quantum computer. So because of that, and many companies, what they need is the way to access other computers in other premises. We also need, of course, the industry pool for the use cases. No, not artificial demos. We need real problems with real data. And also talent pipelines. This is very important, okay? And I want to talk a little about this because when we think about quantum computing, it is very easy to think just in physicists. But no, quantum computing, a community or a research group working in quantum computing needs mathematicians, physicists, people that knows about artificial intelligence. Indeed, I am not a physicist. I am PhD on artificial intelligence. We need an heterogeneous group of people. Okay, so if you have a quantum computing department and you have just 4 physicists, I am completely sure that you are not going to succeed. Because if you want to solve a problem of quantum optimization, you need a person that knows about quantum optimization, a person that knows about artificial intelligence. Okay, so it is quite complex to create a good group. So for this reason, one of the key building blocks is the talent pipelines. And the last one, maybe one of the most complex one, long-term commitment. Okay, we need government, we need companies, we need people that it's engaged with this technology. So the last point is often underestimated and is very, very difficult to obtain along the time. So in Europe, which is the current situation in Europe about the quantum computing ecosystem, it relies a lot in the regional quantum ecosystems. So it is not extremely centralized. Indeed, there are many projects about quantum computing that, for example, we have one which is Open SuperQ, that we are different actors from different countries, and the European Union just found the 50% of the budget, and the other part of the budget should be funded by the regional ecosystems for each of the partners of the project. Okay, so regions, I mean countries, Italy, Spain. So is in these regions is in which the industry is located, the talent is trained, and where public policy can be closely aligned with the local needs. Okay, so at the end of the day, the regional ecosystems act as the anchors for the broader European strategy. And this brings me to talk about the Basque quantum ecosystem. So in the Basque country, we have a huge Basque quantum ecosystem. There are a lot of companies putting their use cases. The Basque country is a region that we have a history, a history related with the industry. So there are a lot of use cases. There are a lot of also research centers such as Tecnalia. So it's a good place to build an ecosystem. So in this case, of course, the ecosystem is not built around a single institution. It's a network of complementary actors. There are some names, but the roles within the ecosystem, or the Basque ecosystem, is, for example, we have BasqueQ, which is an organization that is focusing making the coordination between all the centers, all the companies, the infrastructure providers. We have BKIN, which is focused in scientific excellence and talent attraction. These both organizations are also the ones that pushes the Basque government to create programs about quantum computing. We have a lot of technology centers that are the bridge between academy and the industry. So between the theoretical aspect of the quantum computing and the application of the quantum computing. So we, the technology centers, are one of the most important actors. Also the industry, because they provide the real world challenges. So this is what I talked yesterday. There's a lot of people, and in the Basque country, because we have the ecosystem, there are a lot of companies that heard a lot about quantum computing, but they don't know what can be made with quantum computing. So they come to us and they ask, okay, what I can do with what quantum computing can do for my company, and we need to give an answer. Okay, so it is important to have industry interested in entering this world of quantum computing and to put in their use cases. And of course, the ecosystem works when everyone is focused on their strengths rather than trying to do everything, because as I say, there's no one single actor that could make all the work by itself, okay? So, as looking ahead, what we can make in the field of quantum computing, one of the most important research fields today is to generate hybrid systems, because as I told yesterday, the future is going to be hybrid. It's not going to be quantum, it's going to be hybrid. So we need to build strong HPC quantum systems. Also, in terms of software, there are a lot of algorithms that can enhance the performance of quantum computers with algorithms about error mitigation or error correction. We need more industry-specific pilots. We need to create these use cases to show the people the applicability of quantum computing. And also, we need to create talent, but not only physicists, okay? We need to gather people from computer science, mathematical studies to join the quantum community. And just continue collaboration, the collaboration, because if we don't collaborate, this field is not going to be, is not going to meet all the promises that it is supposed to meet. That's it. I hope you like it, and if you have a question, please.
Do we have any questions for Eneko? No, thank you very much, Eneko, for these insightful presentations. Moving on, we are having the final panel of the day. So the day moves from efficient hardware to scalable intelligence, and the panel on the next generation AI will be moderated by Thomas Olsson Timudas from the RISE Institutes of Sweden, and he will be joined by excellent speakers from Yonsei University, Hyperaxel, Trillion Labs, and Seoul National University. Thomas, would you like to go to the stage and invite the speakers as well?
Thank you. Let's see if the panelists could also join me at the stage. Okay, now I see exactly who. Yeah, good. So thank you for the introduction. So while they're taking the seat, so this panel is about the title is a little bit, it's next generation AI from hardware to software, but it's okay. It's basically the same thing. Thank you. Could you maybe jump one more? One more, yeah. Oh, okay. Okay, thank you. So thank you for joining the panel today and coming out here to the campus here in Incheon. And my name is Thomas Olsson Timudas. If you didn't catch it earlier, I'm a researcher at RISE in the computer science department. So I think, please take some photos of this panel and share it with the participants. Take many photos. Great, thank you. So I would like to first start by asking you to introduce yourselves. Maybe we can start from here. Yeah.
Hello, my name is Sang-Yup Kim. I'm the assistant professor of the Yonsei University, and actually I joined this university from last year. And now I do research on AI semiconductor chip design, specifically the large language model accelerator, or neural peak computing chip accelerator, or neural peak processor or neural processor for quantum computing. Okay, nice to meet you.
Hello everyone, my name is Young Jung. I'm a Chief Strategy Officer at HyperXcel. HyperXcel is an AI chip design startup in Korea, established in January 2023. I joined this company about 2 years ago, and before joining this company, I've been working in management consulting industry for more than 13 years, including the BCG and all environment, also in Middle East and in Seoul. And I'm happy to share my ideas and thoughts on today's topic. Thank you so much.
Hello, everyone. My name is Kyuhee Jo. I am a founding GTM lead at Trillion Labs, and our company was founded to build sovereign AI for Korea 2 years ago. And back then, no one believed in that vision, but now I think we all agree that sovereign AI is a necessity. Right now, we're focusing on building domain-specialized models for enterprise customers. Before this, I was at McKinsey also doing consulting for enterprises, and after that, I was at Palantir briefly, working with Korean enterprises for their AI transformation.
Hi everyone, my name is Jaemin Yu. I'm an assistant professor at Seoul National University. And I just started this job from this March, and I was in KAIST before. So I've been working at KAIST for 2.5 years. And I'm not that related to GPU accelerators and those hardware techniques. I study data-centric AI, and I mostly cover structured data, not languages like graphs or time series or tabular data, which is not super interesting to many people, especially the general audience, but I believe this structural numerical data is more important than languages sometimes, so I would be happy to share my opinions or viewpoints on this AI. Thank you.
Okay, thank you for the introductions. So as you can tell, we have a pretty good coverage from hardware to people working on models and software, and also the business side. So I think this will be very nice. And I think you didn't maybe see the first presentations today, but a little bit just, so why we're here, the Nexus Forum project is really to build this research and innovation collaboration, or maybe not build, but strengthen it, right? Because we already have collaborations with Korea. So we're here to strengthen it and to understand what is happening in Korea, what are priorities in Korea, so that we can bring it back to Europe, because now we are developing joint research and innovation programs and projects, right? So this is the purpose. So with that kind of background, I would be very interested in hearing so from your perspectives, where do you see sort of from a 3 to 5 year perspective, where do you see the big bottlenecks in AI from a Korean perspective now? And anyone volunteers to start, or should? Yeah?
So for the next 3 to 5 years, I wanted to point out probably 2 bottlenecks from Korean industry point of view. The first one is about the supply chain issues. These days, even we are an AI chip startup. Previously, the foundry, like the TSMC's utilization and capacity was a kind of bottleneck for the AI chip manufacturers like us, the family startups like us. But somehow these days, even though we have plenty of the foundry production capacity, because of the other components such as substrate, PCB, the memory, the like DRAM memories, and even other components like the power components, power management components, even though we have the die, the chips, we couldn't supply enough like the end product such as a PCI card type accelerator to the market. That's what we are seeing right now. Because of the whole the semiconductor industry is is in a quite upcycle of the over demand and short of supply. That's what we are seeing right now. And probably the second point is about the power supply. Because of the recent NVIDIA's GPU AI infrastructure system, for example, the energy consumption is almost doubled per every generation. It causes lots of power supply issues to data centers. So even especially in Korea, because of the power supply is not sufficient, and there are other issues such as the permittance from the government about establishing a new data centers. So the AI data center supply is always doesn't meet up the demand in the market. So those are the two biggest bottleneck that I see from Korean market.
Okay, that's very interesting. I think it also kind of aligns very well with the challenges globally and in Europe as well. Anyone else wants to share their perspective?
Yeah, I have a similar view. So from the perspective of a company that is building a model, we are facing a really brutal reality where all the big tech companies are obviously pouring billions of dollars every year in building data center infra, buying GPUs. And if the total number of GPUs in Korea would be well under the amount of GPU Elon Musk single-handedly has. So we have to fight in an environment where model performance depends a lot on the GPU and compute people pour into, but we have very small amount of GPU available on our hands. So that is definitely one challenge that we are currently facing every day. And similarly, I think beneath that is more bigger problem of physical infra, just about the power plants and the data centers that powers the entire AI infrastructure. So I do think there will be a massive build out in the coming 2-3 years, maybe a decade in Korea as well. And we do think that one bottleneck in that build out might be people. So we don't have enough people who can operate these complex systems. So we're actually working on AI models and LLMs that can operate those physical infrastructure. We're working with Korea's biggest power provider on building that sort of basic infrastructure, and we think that will become a necessity in an era where data centers are in the space underwater where humans cannot reach.
Yeah, I think that is also a very interesting thing. We also talked about quantum computing, and also in Europe we are building AI factories, AI gigafactories, and I think I saw a presentation that Korea is also building GPU clusters. So everyone is doing their thing, right, to win the race, but I think there's also an opportunity to share access to these resources, which could also gain, it could be a benefit to to everyone as a whole. So maybe that could also be a way to collaborate, to share these resources. And you wanted to add something to this?
Yeah, I'll be short. So I'm in academia, so I don't know how exactly the industry works these days. But what I see is from we have very great students who are very compatible with doing great research, great engineering, and becoming a pioneer in the AI industry. But I feel we need more so-called big tech companies in Korea so that they can recruit the students who are graduating from these great universities so that they can be proud of being an AI researcher, because our great students at our school are trying to go to abroad, like the United States big tech companies, obviously because they provide more reward, and in there they provide greater opportunities to become I'm really a pioneer of these recent techniques. But it just seems that Korea, even if there is one single company for doing such things in Korea, it would change a lot of things for academia. So, but I don't know how to grow such a company because I don't know how exactly things are going out. But I just hope in next 3 to 5 years there would be some companies like this who can become something like that.
Yeah, and that will be us.
Yeah, great to hear. Good with some confidence. We need more confidence, right? I don't know if what it's like in South Korea, but at least in Scandinavia, we have been a little bit lacking confidence. I guess it's better now. We have a lot of good startups, but yeah, it's very good to hear. And you want to add something, Sangyop?
Yeah, I'm the hardware designer, and in my side, specifically, I think that the software stack is the main bottleneck of our industry or academy. From 2018, I designed several silicon AI chips, but always I need new compiler because the new model was proposed and now the large language models were proposed, and it has many operation types and it has a lot of parameters. So this was the main bottleneck. And I heard that the AI company or industry have the same problem. In most cases, the software company or system company want to run various AI models, but in most cases, they should send their own model to the AI chip company, and they perform the compile, and then they send the compiled model to the service company or software company. So it takes a long time and it spends money. So I think that this is the main bottleneck of our industry. So we should solve this problem to learn various models and develop our AI system. Yeah.
Okay, yeah, that's I think this is a very good way to kind of transition into the next question, which is really about this. If we look at, let's say, again, the same time horizon, if you could build a new kind of AI stack, AI ecosystem, AI stack for 2030, what would you do different from what is done today? What would be different?
Yeah, in the previous question, I answered about the software AI stack. But software AI stack is important, but the hardware stack is also important. And these days, the AI chip design is composed of two parts. One is the logic chip, such as the GPU and NPU, and another part is the memory chip, such as the HBM of the Hynix or Samsung. They design separate chip, and these two type chip are composed into the single chip by using the silicon interposer. And this silicon interposer consumes large energy and low latency, and this is the main hardware side bottleneck. So software side bottleneck is compiler, and the hardware side bottleneck is now the silicon interposer. So I think that we should solve this problem by using the near future HBM architecture. In HBM, there are many stacks, the silicon die, like apartment. And in the bottom of the HBM, it integrates the controller or some logics like multiplexer. And the another stack integrates the memory cells, a lot of DRAM cells. And in most cases, all stacks use the same memory process to achieve high density and high capacity. But in the case of the bottom stack, it integrates only logics like controllers. So it does not need to use the memory process. So we can replace this process to the logic process for high throughput or high energy efficiency. And then we can put the NPU logic, NPU architecture or GPU architecture into the bottom stack of the HBM. Then we can integrate the memory and the architecture into the single chip without the silicon interposer. In this case, we can reduce the power consumption and heat problem, and we can reduce the latency. So after a few years, then we can see the new GPU architecture and new GPU architecture-based data center or other something. Yeah, this is my opinion. Yeah.
Yeah, I think this is something really interesting also, that also this memory is more important, and I think that's very good maybe for Korea. And we have some hardware companies also here. So how do you see this question from your perspective?
Yeah, from the AI infrastructure point of view, I think there is a quite big paradigm shift is happening. I would call it from the homogeneous computing system to a shift from the homogeneous computing system to heterogeneous computing system. You probably have seen what Jensen Huang presented during the GTC. That was the combination of the collaboration of the GPU and Grok's LPU. Grok is the company that NVIDIA acquired recently. And the way the NVIDIA's approach using Grok's LPU is by dividing workload between GPU and LPU. So GPU is mainly responsible for the attention part, while the Grok's LPU is taking a role for the feed-forward networking part. So they are allocating different type of workload to optimize the whole system. And NVIDIA is trying to build the whole optimized ARC infrastructure system by themselves, by acquiring new techniques and companies. And so at Hyperxel, we are also developing a processor called LPU. To be honest, we actually use the name before the Grok's LPU, even though they have the trademarks for that. Anyway, so our approach is that we are trying to focus our LPUs, the workload for the pre-fill stage, then decoding stage. So we are trying to optimize the AI infrastructure using both GPU and LPU, but to be more cost efficient and power efficient than NVIDIA's GPU system. And what I'm seeing in the future is that more diversification of the devices. So there will be an AI infrastructure using GPU, NPU, LPU, and maybe even the DPU, data processing units. So they will work together and collaborating together to optimize the cost and maximize the energy efficiency. Since like I mentioned, the power supply is always the bottleneck for the whole system. I think that's one transition that I'm seeing. So that implies to the software ecosystem that previously the most AI software or solution software's primary objective is to utilize the most basically maximizing the utilization of all the GPUs in the system. So make sure that there are no idle GPU, which is very expensive resources for the companies. But in the future, I think it's orchestrating the multiple different devices within the system, maybe at the rack scale or even to the cluster level or at the data center level. That's what I'm kind of seeing in the future.
Okay, that's very interesting, and I think this also focus on energy efficiency is a very big topic in Europe. Just so Europe has for a long time been about energy sustainability, so it's a core principle also in Europe. And I have some other follow-up questions, but maybe first I would like to hand over maybe from more of a model or algorithm side. Do you have something you would like to add to this?
So you mean in terms of the AI stack? Yeah. Well, I don't know much about the stack. I just study the models. So if I can answer in a way of how I see how these models are developed and how these algorithms are developed, so I am a researcher, and I think the language models, especially the large language models, there are not much to do in that area, because I see that almost all industrial companies are pushing their limit to make the language models better, and they have moved from making the models larger and models smarter into a better way of using these models, like by creating agents, by creating workflows, because each model is already good, we can say. So they just know it is important how to use a great workflow that combines tens or even hundreds of models into doing a greater thing. So from my perspective, that kind of orchestration is not something that researchers should do, because I want to see the next level of that. So what I'm currently recently interested in is applying the law of scaling, which we have seen from language models into other domains, like for instance numerical data. For instance, if you think about the tabular data, we know that almost all companies store their data in terms of numbers, like tables, especially the relational databases where each database contains a single aspect of the company's data. And these hundreds of databases or even thousands of databases create what the company is. We can say that define what the company is. And by looking at this data, we can know we can create an AI personalized to that company, not a single person based on how he or she talks to the AI, but we can broadly understand how this company works in the world and what would be the position of this company in the world. So what I'm recently interested in is to build a foundation model, or we can say build a reasoning capable model that can work on tables or numbers, which a model that can instantly see a pattern from databases and can look at what would be the next numbers that would arise from a table. So such a thing, or we can say a time series foundation model or a video foundation model, which is often called the world model. These things are like people, I just think people are thinking about what would be the next language, what would be the next structure or knowledge that can create the next like breakthrough in the AI. So, and among that, I especially am interested in these numbers like tables. So I'm sure, okay, it's hard to be sure, but I'm confident that someone will make a breakthrough in that direction. So that's what I'm like currently working on.
So when I look at the future, I think there are two different views in the industry. So one part is sort of the Anthropic's OpenAI saying that there will be like one massive model that's an AGI and it dominates everything, everyone will use that model. And then the other, part of the story is Jensen Huang and sort of the Hugging Face CEO saying there will be more smaller domain specialized model. And some people even going so far as to say AGI will be a model of a size that can fit in a personal laptop because of how efficient the algorithms will become. I think realistically the future will be somewhere in between, but I definitely see the need for like smaller domain specialized models, especially in the enterprise environments in Korea. Because if you look at the current large language model, they are like spikes. So they're really good at one task where they have a lot of data and it's easy to verify, like software engineering or writing, it's easier. Then there are some other domains where the data is scarce and it's really hard to verify because the kind of work is verified only after like 10 years, 20 years. So you see that models like Anthropic's one is Claude is so good at computing, but if you make it do something else, such as like understanding PNID diagrams or something really technical related to manufacturing in Korea, they're not that good. They're not as good. So it doesn't solve the problem in the industry. So I do see a future where these enterprises would become more willing to invest in their own domain specialized model. And in order to support that, I think the necessary infrastructure is sort of the NPUs that companies like HyperXL is building that enables these models to be ran on enterprise environment and not in like hyper data centers.
Yeah, I think this is a very good basically transition into the next question, which is, as you mentioned, you have this AGI approach. They want to kind of solve superhuman intelligence. But then you also have the, pragmatic, okay, let's create economic value for the companies. So what do you think then would be, where would you put focus to scale from, to advance from AI proof of concepts that work in demos to something that can be used reliably in enterprise systems? Do you want any volunteer?
Yeah, I think that's a very good question. It's also a very difficult one because when I was at Palantir, we had this one client that we've worked for about 2 years, and we had already built like 3 different solutions for them using Anthropic's API. But none of them were actually used in the day-to-day practice. So this company basically spent $1 million on Palantir and no one was using their platform. And I think the reason is because of the way the project was set up. We would go in there and build a solution for 3 months and then leave onto a different department to build another solution for 3 months. In reality, for a single solution to be adopted within the organization, it requires a lot of babysitting, a lot of like, hey, come try to use this thing. What's wrong with this? Why are you not using this? And a lot of iterations. It's just like software, just like building a software company. So I think that's something anyone trying to build an enterprise AI solution or do like an AX consulting business should know, is that it needs to solve the real problem, and you need to talk to the people who will be using it. You can't just talk to the enterprise leadership and try to like convince them that it works. You should really need to talk to the people doing the workflow, maybe take a seat next to them and look at where they're failing and try to build a solution that actually fixes it. So I don't think it's just like model capacity problem. It's more like understanding the people, and just it comes down to the product principle that has been true for the past like few decades.
Yeah, so the following the great answer, I just think there is a large barrier in applying AI to enterprise, because people who decide to bring AI is not the people who use the AI. And in fact, the people who need to use the AI would be the people who would be replaced by that AI in a bad perspective. So the problem is they do not want to share their like knowledge or ideas because they fear that they're gonna be replaced if they share everything. So that's the problem happening in many areas in industry, because people have seen some jobs just are removed because AI has been so good. So people are fearing about AI becoming so good, so that I mean, instantly that creates walls between people and between sharing the knowledge between people and AI. So it's hard. It's a hard thing. And one thing I agree with the previous answer is that there is I guess, big two directions, which is to create the large foundation model, which can work with like ideally for different domains and problems. But at the same time, we can build small, efficient like task-specific models and adopt these models to different enterprise so that they can work in a more cost-efficient way without worrying about like having this large GPU cluster inside the company. But the problem is, what I personally believe is, if we have to put some energy and cost for building this task-specific model, then that creates a second wall. The second wall is just to get in touch with these people who will be using AI, but the second one is to create one from their knowledge. So what I think is two walls are too difficult to break at the same time. So what I really want to is, the model side, we need to build a model that is mostly generalizable as possible so that we don't have the second wall at least, because the first wall will be there. So with the second wall in hand, if we can instantly adapt our model to every task, for instance, in days, then probably we can convince them to share at least some knowledge on how to use these models, and that might be, well, a potential solution in the future.
Yeah, maybe also part of it is, like you said, this problem that AI, some companies want to replace people by AI, right? Maybe we need another approach to how we, also from an economic or societal point of view.
Yeah, I have another opinion. To scale, in Korea, there are many AI chip design companies, but in my opinion, to scale their AI hardware system, we should solve the money problem. In these days, the many Korea investment company and government gave the money or funds to the AI chip company. But actually, to be honest, the AI chip company just rely on the investment fund. So actually, in worldwide, there are few companies which earn much money by selling the GPU chip or NPU chip, just NVIDIA. So we should find another strategy to earn much profit. So there are many strategies. The NVIDIA strategy is to making the good data center GPU chip, but everyone do not want to use the data center GPU. For example, for the television or refrigerator, they do not need to high performance, and they don't want to expensive chip. So In this case, if we can make the cheaper or the lower power chip, then we can sell many chips because many people use the refrigerator or television. So we should find another strategy to earn much money. Yeah, so we will solve this problem. And as I know, in the case of the smart glass, few weeks ago, the Meta and some companies told they will develop the smart glass. And in the case of smart glass, many companies use only one chip, the Qualcomm's chip, and there are no MPUs which is made for the smart glass. So we can use the strategy to sell our new chips for this market. So after we earn much money, then we can move to the next level and we can scale our chips system. So that's my opinion. Yeah.
I think there's also something you mentioned now that we also touched a little bit before, which is the software stack and ecosystem, which is very NVIDIA based, CUDA optimized, and it's easy to develop for this kind of, like you said, data center, GPUs. So from the hardware perspective, how big of a kind of challenge is this CUDA NVIDIA dominance for you? And what do you think there will be needed some kind of new initiative, some open ecosystem to have this, embrace this kind of heterogeneity of hardware platforms? What's your perspective on this?
So I think it depends on like what type of AI services we are talking about. Like the first generation of AI model was based on the RNN or CNN models, and for that era, I think the software, especially the CUDA, the ecosystem was a big barrier for other startups to enter to penetrate into the market. But for the LLM, the transformer-based model architecture, there are quite standardized frameworks such as VLLM or the SGLang. And the enterprise users, I mean, as long as they are providing services using those standardized framework, I think it's now easier than before for the MPU startups to develop the full stack softwares. And since we are using the VLLM framework and the PyTorch or Hugging Faces, they are quite like standardized formats these days. So I think it's easier than before for sure. Still, I mean, CUDA's ecosystem is quite a big challenge for us, to be sure. However, I think in the future, the software part will be easier and easier because now, as you see, lots of the coding AI agents are helping people to adopt new MPUs and adopt new the softwares as well, like the software development kits, because we are providing the agentic AI services even for our potential customers to create the kernels or the APIs optimized for their own services, and we are using the AI services only for that purposes. So it's still, I mean, it's fair to say that NVIDIA's CUDA ecosystem is a big barrier for all the NPU startups, but I think the barrier will be minimized as time goes by, I think.
Okay, yeah, thank you for this perspective. It's very interesting to hear it from someone who is really developing this hardware. I would also now like to ask you a question that is maybe also a little bit tricky. If you could please also answer a little bit short. So what do you see as a promising AI technology that doesn't receive enough attention and funding today?
Yeah, in my opinion, the neural computing, which mimics the human brain's operation, did not receive much attention compared to their potential. Yeah, in human brain, there are many neurons, and each neuron transfers the spike to the next neuron when its membrane potential exceeds the threshold. So when it does not receive any spike, then it maintains its idle state, and it does not consume any energy. So due to this event-driven characteristic, the human brain system can consume low energy. And neural computing's main purpose is mimicking this characteristic, human brain's characteristic. So the many companies like the IBM or Intel developed the neural chips called by the Loihi or the Turnos or Nospol. And until now, the neural computing could not achieve the high accuracy because the engineers want to mimic the human brain's training methodology, bio-inspired training methodology. But human brain's training methodology is very difficult, so the engineer cannot achieve high accuracy by mimicking this training methodology. But these days, many researchers did research for how to train this neural model accurately. So these days, we can easily achieve the high accuracy compared to the CNN or transformer. And specifically, the IBM designed the Notebook, which is the new neural chip, and they compiled the large language model to their own neural chip, and they reported that they can achieve higher throughput and higher energy efficiency compared to the NVIDIA's A100 or H100. And moreover, they can achieve almost same accuracy compared to the conventional GPU's operation. And their next step is that let's make the large-scale neural computing system by using this event-driven characteristics. So in the near future, they may achieve the higher accuracy or higher energy efficiency, and they may replace the current GPU system. So I think that this computing method and this processor have the very good potential to reduce the energy consumption of this world. Yeah, so yeah, that's my opinion.
Yeah, and you will be happy to know that Europe also is very interested in neuromorphic computing.
I know.
Yeah. Anyone else wants to add something?
There's one architecture for language model that is quietly gaining traction. DeepSeek first proposed it. It's called memory architecture, and we think that, Facebook and Google has also came up with something similar. And it's an architecture that offloads knowledge into memory, not like the GPU. And that sort of makes the entire model more efficient. And more importantly, the way current language model works, it sort of mixes inference with memory. What it means is that if we ask it like a really obvious factual question, like where is the capital of South Korea, it will use the entire layers to infer where the capital of South Korea is, rather than just looking it up from its own memory like we do with our brains. So we personally think this architecture is really interesting, and we are trying to experiment it internally at Trillion Labs. And we do think that this sort of more efficient architecture could be a better fit for enterprises, especially when we can retrain this memory module separately to sort of inject domain-specific knowledges without having to retrain the entire layers.
I think you will also be interested in talking to Stefan, who is waving. He has some other similar, yeah, very interesting. And do you also want to add something?
So I would say scalability, because these days, every aspect of AI is getting attention. So I just think, I'm not saying that scalability is not a thing that people are not interested in. But scalability is important because following the previous question, we have a lot of data, and most of the people find it's convenient to use AI. Even for me, I use AI every single day for finding restaurants, for doing writing or reading everything. But so I guess the word context is very common these days, but the context is a general history of conversation between me and like AI. But if the context needs to expand to the whole database of the enterprise, then it becomes a severe problem, because the AI is not designed to support such a big data, and it tries to remember this data inside its parameter perhaps, but it's not just working because it is not designed in that way. So I'm also interested in the memory architecture, because that's how humans behave. Like, we don't memorize all the things inside our brain. Our brain is most likely a very efficient, cost-efficient inference engine, which can instantly refer to the external data source in a very short amount of time. So maybe AI needs such a thing. And for implementing such a thing, we need to design a memory architecture for an AI, because database is obviously for humans. AI will be there. There will be optimized memory structure for AI, which can be totally separated from the inference engine. Then the engine itself should be much more cost efficient and lightweight, while the memories can be stored in a more reliable manner outside GPU, so that it will also result some large reliance on GPU cluster, because in that way we don't need the large GPU memories anymore. So I also believe that would be a really important next direction of AI.
I think you will also be interested in talking to Stefan. Yeah. Do you also want to add something
well,
before?
I don't have much idea on this, but I'll say that we are very interestingly looking into the world model, but I think there are no dominant models yet. So we are quite interested in it, and we are interested in a way that what could be the specialized architecture from the semiconductor design. If you have any good ideas on that, please let me know. Thank you.
Yeah, okay. Thank you very much for these insights. I think one last kind of question. So if you could kind of propose to Europe, what could a good collaboration, a concrete in the coming year, what would you propose that we should do this together, Europe and Korea? Anyone volunteers?
Yeah, in my case, I want to collaborate the industry which design the European computing chip. As I know, the IBM research in Chile made some European chips, and they measured some AI applications to report the energy efficiency or the power consumption. So they already have a good test bed. In my side, I focus on designing the European computing AI semiconductor chip or European model, but we have many challenges because we are academic. But in the case, in Korea, there are many researchers who focused on the European computing modeling or chip design. But in Korea, there are few companies for European computing or European computing chip design. So if we have a chance to collaborate with the industry in Europe or the university in Europe, as I know, the Europe's industry has a good expertise, but the academy also has the good expertise. Specifically in the case of the ETH, Chile has many good researchers for European computing, and they have a good strong point for designing the system level design. In the case of Chile, they designed some AI-driven system with the European computing chip or European-based sensor, and they have another many systems, a robot system with the European computing chip or European computing model. So they have a really good test bed and good system and good application demonstration system. So if we can collaborate, then we can make good synergy our Korea side, we have many good AI semiconductor chip designer. So I think we can make a good synergy. Yeah.
I think in some ways, Europe and Korea is in the same boat because we used to rely on like America's technology, Palantir, let it be Palantir, let it be OpenAI, but we are also simultaneously seeing the changing world order. I don't think it's no longer that America is sort of the peacemaker of the society, of the global, and we all try to become more sovereign. We're trying to move away from relying on America's technology and trying to build our own and try to build our own models and everything that supports our own economy. And I think Europe is also sort of doing a better job than we are in that they have a really like good company, Mistral, that is changing a lot of ways and providing models to really good big companies in Europe. And that's something that we want to learn from. So I would love to, if anyone knows those sort of companies or people who've been involved in that process, I would love to talk more about that and try to bring those practices into Korea as well.
Yeah, I would just suggest, I know that there are many kind of these things but prestigious large student exchange program between Europe and Korea. Because what I really want to show is Korea is good, like Europe is good, although it seems like the US is getting all the attention in terms of AI from the world. But I personally think it can always change like instantly because I personally think AI is, I mean, I know it more about the GPU, but I think it's a matter of more about people. With great AI researchers on hand, we can always become the best in the next direction of AI because AI is changing fast. But many students don't think that way. Many students think we should go to the US, I mean, we should get the job at the US, or we should go to, we should go to the like PhD in the US because that's why what they believe in to be a good AI researcher or AI engineer. But I don't think like that. So if we spend some money, European governments and Korean governments spend some money and motivate the students that we are good, we are ready to provide you any monetary or any supporting environments to make you a better in this job, then that would be a motivating thing to the students.
What I'm witnessing these days is quite frightening, to be honest. As you saw from the recent two wars, AI is a kind of very essential part of the defense system and defense essential infrastructure as well. And as she mentioned, currently AI ecosystem is quite dominant by the US. Like for example, the AI infrastructure like GPU is their market share is probably 99% of the market for the whole recent AI infrastructure. So, and I think the Korea and Europe should collaborate together to fight against the US dominance, I would say. And what's needed for this this supply chain system is that as a hardware design company, we would like to know more about the workload and actual service environments and infrastructure environment like that. So what should be the optimal device or infrastructure strategy for the European companies? And especially like I know there are certain the chip design startups in Europe as well, such as GraphCore and Accelera, and there are others too, but in terms of the foundry, the production and fabrication, there are no foundries in Europe. So, and Korea, luckily, is positioned quite neutral between the US and the Europe. So I think it's a good partner, and I think we should exchange more ideas between the Europe and Korea together to develop our own kind of protected ecosystem for the AI infrastructure.
I think these are very nice, very interesting things to hear. And, you know, like you said, Europe, South Korea, we're kind of in the same boat, and that's why we're here, right? And we heard yesterday that, you know, Europe is very much into sovereignty. And we are talking about made in Europe or should it be made in Europe, maybe expanded a little bit, and for example, South Korea. So I think it's really important to build these bridges, and can we work together against this kind of dominance. And I also think there's one thing I hear consistently in Europe, which is similar to what you just said. We want to know what are the needs of different applications, what do the workloads look like. Even in Europe, we also struggle with this. I think maybe it's a thing for the AI factories to have a little small test bed kind of thing where we can test other new hardware architectures with the workloads in the factory. Maybe that could be an idea. Yeah, great. Then I think everyone wants to talk to Stefan. Yeah, I think this has been a really insightful panel and discussion, and really interesting to hear what you're doing here, both the things that you do that we don't do, but also the things you do that we also do, right? So I hope you can stick around for coffee afterwards and we can talk a bit more. And thank you very much.
Thank you.
Thank you.
Thank you, Thomas, for the moderation and the flood. And also thank you to Sangyub, Youngwoon, Kyuhee, and Jaemin for sharing all the knowledge, best practices, and really, really nice wishes at the end. So we hope that they do come true. So in the meantime, of course, we invite you to join us for the coffee afterwards, where we can make those wishes come true in a form of collaboration as well. So to discuss whatever you wanted to discuss from whoever from the audience, that is the moment. Now we are approaching to the, let's say, dynamic segment of the program. The research project pitch session. So I'm pleased to hand the floor over to my colleague from F6S, project manager Tajana Medakovic, who will moderate pitches from the GRASP, AIOLIA, and the INPACE project. So Tajana, the stage is yours.
Thank you very much. Good afternoon. For those who just joined, thank you for joining us. It's a pleasure to have you here. I will be brief given the time. Yesterday, we had presentations from different projects from, let's say, an industrial perspective. Today, we focus more on the research. And I would just like to share a thought that had left a big impression on me yesterday. So the NCP for South Korea, Maya Kim, has mentioned that when the funding started, investment started flooding into South Korea, that it is a land of mountains. So there was a question, how to direct these fundings? What's the most important thing? And then there was a decision that most important resource are the people. So the funding should go towards the research, the knowledge. I cannot speak for the Korean case, but I think I can say that for all of us, this remains relevant even today, and that the funding towards the research, towards investing in people, remains as a path forward. It is my great pleasure to invite the first speaker to the stage, Professor Jin Chang. He's a professor at Advanced Display Research Center at Kyunghee University. I hope I pronounced it well. He will be presenting today the GRASP project. Professor, you can also take the stage there. I think there is there a microphone? There is, yes. Yes, please. Thank you.
Okay, thank you very much for your kind introduction. So I am very happy to have opportunity to speak today. So at the Nexus Forum between Europe and South Korea. So my name is Jin Jang from Kyunghee University in Seoul. So it took 1.5 hours to come here. It's my first time to come to, Yonsei University, international school. So we are working with the European, so EU project. The name is GRASP. So the Green Agile Semiconductor Production. So this one is our project, name. So that today, because of a time limit, I will focus on international research collaboration. So that, recently we are using flexible hybrid electronics. For example, your smartphone, so you use flexible substrate, PI substrate, and the electronic component are conventional, made of silicon chips. But that, product cannot be suitable for fast-moving consumer good because of high price, thickness, very thick, and also weight is very heavy. So that we try to replace those, components with a flexible counterpart. Then we have a lot of application. You can see in the bottom, so flexible RFID for, fast-moving, consumer good and also medical application. So that the object of our project is to develop, so flexible MCU. MCU means microcontroller unit. So including CPU and memory, everything by using a thin film, not a conventional, silicon process. You can see here, and some power supply and the sensors connect from outside. Okay, so here is international partners. So Korea, our university, KHU, and the UK Pragmatic Semiconductor. So this one, only one company in UK having a 12-inch semiconductor fab. And Germany, France, very well. And Belgium, so KU Leuven, very near to IMEC. And France, CA, very near to Ecopolytech. And Ireland, University of, National University of Ireland. Okay, Pragmatic Semiconductor in UK is a leading, organization for our project. So they have a facility to do IC design and the flexible microprocess design and manufacturing, and TFT device modeling, characterization, and flip chip fabrication and testing. So more than 200 people working for this project, and they try to develop ultra thin, so flexible chip, flex IC. So using oxide TFT, you can see in the bottom. So they made this one a few years before. So our university, we are working on thin film transistor for a long time. So that to reduce the power consumption, we need a CMOS technology. So that we are using a P-channel polysilicon and N-channel oxide semiconductor. Oxide semiconductor bandgap is higher than 3 electron volts, so that the leakage is very low. So your smartphone, almost 100% using this kind of device structure, LTPO we call. Anyway, so Fraunhofer in Germany, they have a technology for chip assembly, packaging, and testing. So they have a technology for bonding and on PI substrate and the formation of electrode and testing. So German, And KU Leuven. So very near IMEC. IMEC is very famous, semiconductor fab they have. And KU Leuven, they have a technology for, IC design, the simulation, design, testing, and including memory and the microprocess, so that they will do a flexible microprocess design and the memory. And so one of our PhD students will be in my lab for collaboration. Okay, and in France, so CEA is a famous research organization. So this one located very near in Eco-Polytech, so Farajo. And they are in charge of machine learning and AI to realize low power, high performance, flexible, intelligent electronics. Okay, we need application so that we have, National University of Ireland team, Tyndall Institute. They have a lot of experience for the medical application, so that they will use this flexible, so microelectronics for the medical application. Okay, the research target is to flexible MCU. If you saw this one, so CPU 100% using a silicon chip, but we want to make CPU on flexible substrate by thin film transistor. This is first approach. And memory also, DRAM, SRAM, and clock generate a lot of circuit, and some battery and some sensors outside, you can see here, and connected by, German ground-up. So our lab, so ADLC on the right-hand side, you can see. So we work for TFT for a long time. So the leading organization in the world. So that we are working on TFT device and the circuits such as rectifier, ring oscillator, DRAM, SRAM. And also to reduce power consumption, we hope to use high-K dielectric. So one of the results we developed, so zirconium aluminum oxide, GaO, zirconium aluminum oxide. We have a technology to use this high-K for TFT to reduce the power consumption. And this is 1 micron channel length, oxide TFT. So in case of oxide TFT, short channel is very difficult to achieve. So very high mobility, you can see on the right-hand side, y-axis mobility is over 80 and 1 micron we developed. And after that, we developed 0.3 micron channel length, transistor also. Okay, so that, job, classification. So UK, they are in charge of product, CPU, memory, and evaluation. So Korea is mainly CMOS, TFT, and circuit. And Germany is component assembly, flexible. And Belgium is, they have the simulation, design, microcontroller unit. And France is software using AI and machine learning. And Ireland is medical application. So there are a lot of application we can find in the future. So the 2 examples you can see in the bottom, RFID in fashion accessory, and on the right-hand side, the medical kit, also RFID. So we need a very low cost, very low power consumption, very thin RFID for those application. And there are so many other applications also. And so in technology point of view, we want to develop some new technology, platform. So for flexible, electronics in the future, so that we are working on the, for example, thin film transistor, CPU, and memory, and other circuit to reduce the cost and to reduce the thickness and to reduce the weight. Okay, so that every year we have an offline meeting. So here is the UK. Last year, 1 year before, at PSL, Pragmatic Semiconductor. So you can see. And last year, September, so because of 2 years, this product is 4 years. So after 2 years, we need to have a review meeting, so that in Belgium we had a whole day review meeting. A lot of questions and answer. And every month we have a monthly online meeting. So we discuss some technical issue and the future, So thank you. Thank you. Thank you very much. So any question, comment?
So if there are no questions for the time being, I actually have one question for you. So you were showing us the utilization plan and the effects, and you mentioned that results are anticipated to be groundbreaking in medical wearable markets. So how difficult is it to make breakthrough from research to market, especially when you are pioneer in a certain domain? So what are the future challenges for the project?
Yeah, so that this is a very early stage of a new technology. So that we have one group for the medical application, so from Ireland. So that is one example. And also, Pragmatic Semiconductor, already they have a RFID, product. So that we want to improve that product by reducing the power consumption. So power is the most important factor. Yeah, so that the market, we have to create a new one. And there are many also technical issues we have to, develop.
So still a lot of testing and challenges ahead, but seems doable, I would say. Professor, thank you very much for your presentation.
Okay, thank you very much, everybody.
It is my pleasure to announce the second speaker, Chi Yong-sa, Senior Researcher from Science and Technology Policy Institute. Please, the stage is yours.
So, good afternoon. My name is Chiang Sao, and I'm working at Science and Technology Policy Institute, STEPI. Today, I would like to introduce our project, AIOLIA, in 10 minutes. So, AIOLIA is a project for operationalizing ethical principles. AIOLIA is a project which is funded by European Commission, and it began in February 2025. So we have just passed 1 year mark. I start the presentation with the background of this project. As you know, there are numerous ethical principles which has been proposed at the global level and national level. However, I think there are still big challenges is remained, which is how can we implement the high-level ethical principles into the practices in the development of AI and in the use of the AI? AIOLIA addresses directly this question. So, this project tries to find out the way of the bridging the gap between ethical values and practical implementation in AI development and AI use. In order to achieve this goal, we have set the research objectives in two ways. The one is development of ethical tools for AI developers and AI users, like guidelines and the technical measures and organizational measures. And we provide the, we would like to develop a training program in the tailored context. The research scope can be described as the following: the impact of AI on human cognition and behavior, particularly in healthcare sector and workplace and personal life. So, in order to make progress, the research, research contents and research plan, we have taken the methodology, the bottom-up approach as the methodology to find out the way of the bridge the gap between ethical principles and the practice. And as you see, there are 20 research teams across the continents. The teams from EU area and as well as the team from Korea. It is us, STEPI, and the team of the Japan and China also participating to the project. AIOLIA is not, AIOLIA pursue to create the practical, influence in the AI policies and the AI practices too. So because of that, we try to use the international research platforms and as well as the international regulation platforms too. Now, I would like to tell you about the Korean case a little bit. We conduct the use case study with the communication AI robot for senior citizens. So, Korea is the most, the fast aging society. The population of the seniors, 25 years old, is really increasing very rapidly. And in order to provide the care service, the good and the better care service for the seniors. Nowadays, the Korean government try to provide the communication robots for the seniors very actively. Yeah, this device can, at first, make a dialogue with the seniors. There are, the seniors who don't have any chance to speak with someone for all days. So with this device, we can reduce the psychological pressures of the seniors in some level. And with this device, we can respond the emergency situation more rapidly. So in this side, in this dimension, we can benefits of this device, but in other side, there are also some risks which can occur by using this device. For example, the seniors can be overly dependent on AI, and the seniors may face the discriminatory outcomes if the AI systems, AI has failed to use to build up the non-biased model, or after the adoption of the AI in social service, the invisible invisible work, or we can say the shadow labor, could be occur by using the AI for senior service. So in this circumstance, we have set the 3 AI principles in the senior care sector. The first is safe human-AI relationship. The second is fair AI service. And the third is promotion of social welfare. And we have proposed the adequate technical measures and organizational measures to reduce the tension between these AI principles and the practices of the care services. Now, I would like to tell you the benefits and expectations which we could have through the conducting of the AI IOLIA. These benefits and expectations could be divided. We can see in 2 dimensions. The one is the cooperation with the international experts. We can share the insights and knowledges of the international research and policy trends through the meetings and the workshops, like these photos. Like the project, the previous presentation was introduced. We also meet monthly, and between the monthly meeting, we have also the small group meetings too. And we exchange the research results very intensively. And the other benefits could be that we can have more chance for promotion of the research result, our research results in the global level. And the other dimension of the benefits and expectation could be occur through the cooperation with the Korean experts. By conducting the use case studies, we meet very many stakeholders from the industry and from the policy making side, and as well as the academic side. So we make an research network, kind of transdisciplinary research network related to the AI ethics we can make in Korean society. And the other point we can expect is that we facilitate the engagement with diverse policy stakeholders through open conferences we provide. Actually, in the last week, we had a conference in Seoul and talk about the AI ethics with the relevant stakeholders from the policy side and the industrial side. And there we have presented the AIOLIA research results too. So in the remaining, for the remainder, we try to exchange more intensively with the international partners and try to create meaningful research results. Thank you for your attention.
Thank you very much. Are there any questions? Okay, in that case, I would also like to ask you something. I think that this is a very interesting project, and this balancing between ethics and different legislations probably is a great challenge. So how do you actually aim to solve this, to balance these different legislations when it comes to use of personal data, such as elderly citizens, for example?
It is really difficult to get the personal data from the seniors directly. If your question is oriented to our case study, then we don't gather the personal data of the seniors. Instead of that, we focuses on the way of the gathering the personal data, which gather the industries to develop the AI model.
So it's like anonymized data that is collected, like some specific symptoms, those kind of data, or?
Yeah, the industry gather the personal data of the seniors, like the age and the other simple personal data. Additionally, whether he or she take some specific medicine, or when they sleep, when they go to bed, and what is their personal
like the creation of some patterns or habits, if I understood correctly.
Yeah.
Okay. Okay, this sounds very interesting. Thank you very much. We have the last project for today, which will be presented by Jae Sung Song. I hope I pronounced it well. Professor at Sejong University, talking about INPACE project and initiative. Please, the floor is yours.
So today I'm going to introduce about this INPACE initiative. This is like a collaborative project between European countries as well as Singapore and India and then South Korea and then Japan. So the main intention of this INPACE is to engage the researchers and then industry and then society under the framework of INPACE to have more collaboration based on the digital partnership among those countries. So first I will try to introduce why this INPACE is important. Because the EU aims to strengthen its connection to Indo-Pacific region. So EU saw Indo-Pacific region is very important for the future collaboration. For research and innovation, technology, deployment and regulation alignment, and supply chain stability, and so on. And then also it is very important to promote of digital technologies being one of the highest priority. The EU has established digital partnership with Japan in 2022, and then South Korea also, same like 2022, and then Singapore in 2023, and then with India, it's a Trade and Technology Council in 2022. So as you can see, Europe is trying to extend its digital partnership with Japan and Korea and then Singapore and then also India. So you can see that Indo-Pacific region is a very important area from a European perspective. And then we are all sitting together in that area, right? And then the goal is that society and business in both regions benefit from opportunities in the growing global digital economy. So basically, this INPACE project was started in 2024 January, and then it will continue until next year June. So it is 3.5 years. So with this framework, 21 consortium partners are engaged in this INPACE project, and then also 13 Asian and European countries are in partnership of this project. The funding is from Horizon Europe and Swiss State Secretariat for Education, Research and Innovation, SERI. So the mission of INPACE is to support digital partnership and the Trade and Technology Council and to contribute to the deepening of the collaboration between Europe and India, Japan, the Republic of Korea and Singapore in the domain of digital technologies and their application for the well-being of the citizens in Europe and the Indo-Pacific region. So it includes all the technologies and then services and applications that you are thinking related to digital things. Like AI is also part of it, and then 5G and 6G is also part of it, and then doing some research on semiconductor also part of it. So as you can see, the main mission is to engage those different development technologies and business and society and so on. So to achieve this mission, INPACE will work on 3 levels. First one is establishing regular exchange between leading experts from Europe and 4 partner countries. Because you all know that meeting to each other is the most important thing. If we are separate and then we are not exchanging any information and so on, even you are doing like a look at research, look at science, whatever. Maybe it's good, but still, to make it better things, we need to exchange our information and then collaborate each other. And then regular meetings is very important. And then also supporting the digital policy dialogues on the governmental and then in institutional level is also important. And then informing and involving a large community of stakeholders in Europe and then in the partner countries into the dialogue via online and in presence event via the INPACE consortium platform. So using those 3 mechanisms and 3 levels, we try to achieve our mission. So how to engage with this INPACE. So we have the INPACE hub. So this is the framework. So if you want to join, and then if we want to look at, and then if you want to collaborate with us, or the partners in the member of INPACE, you can come to this INPACE hub, and then you can register yourself, and then you can get several, several resources, as well as you can find out some partners that you want to work with. So this is a quite good framework to collaborate each other. So you can find out this link here, and then if you visit there, you can easily register yourself and then promote your work, and then also collaborate with others. So this hub actually provides various services, like expert connection, and then share workspace, and then event management and analytics, and we also provide virtual fairs and so on. So those are some key figures. Currently we have 650 members, and then 74 news, and then already done 43 events and so on. So you can see like webinars, online webinar, and workshop, conference, and so on are all held in INPACE for the previous 1.5 years. And then we will continue to do the similar things to the next year, okay? And then thematic working group is also the core of this INPACE project. So we have those 5 thematic working groups. First one is digital dialogues, policy and education. So in this working group, we are talking about standardization, policy dialogues, and so on. And then for the second one, it is innovation and presentership for sustainable well-being. And then in this thematic working group, we have done like a public administrations, infrastructure and services. And then for third one, digital technologies, trustworthy decision support. Like nowadays, trust AI is very important, right? So how to guarantee the trustness of AI, and then also data technologies, and then also high performance computing. Those are all part of this thematic working group 3. And then 4 is enabling technologies like chips for futures and so on, like advanced computing, advanced functionalities, and then groundbreaking technologies. Those are all handled and then discussed in this thematic working group 4. And then for the thematic working group 5, it's about digital technologies, future networks. So 5G beyond, like a 6G, and then Internet of Trust, and security, and smart continuum. Those are all handled and discussed in thematic working group 5. So what are expected outcome of INPACE? Like harmonized research and innovation, funding program, and joint calls. That's one of the things. The second one is convergence on principle in regulation, legislation, and standard for digital technologies. And for the third one, reduction of barriers for trade and commercialization of new digital technologies. And the fourth one is long-term collaboration in the field of digital technologies. So those are kind of the things that we are expecting, and then try to push to make it happen. So we really want to, your engagement, and then your involvement, and then to collaborate with you in the framework of INPACE. And then some of the example opportunities, like and previously what happens, like 2024, we had the first INPACE symposium in Seoul, in Sejong University. And then last year, we had the EU-Japan Digital Week took place in Tokyo. And then also last year, we have a Digital Partnership Conference. And then early this year, we have, last month, we had second EU-Japan Digital Week. And then in that Digital Week, we had like a digital, data hackathons and so on. We have done that. And then we are looking to connect with LIA and move from talk to actions, and action which are seed for following interactions and project. 6 has already been done, and then we are currently something ongoing, and then also some under preparations. Like a cross-domain data exchange plug test, and then digital public infrastructure interoperability hackathon last year, and then currently we are doing, preparing disruptive semiconductor technology test bed, and then NICT ESA project on 6G. And then we are preparing digital public infrastructure interoperability hackathon, Tokyo this year. And then AI Ready Data Challenge, September this year, we are currently preparing in Seoul. So, I mean, not just, those typical INPACE things, but also the member of INPACE partners, we are also doing some small project together. One of the things is this estimate project, which is like providing a standardized IoT cloud, Edge, and Continuum project based on the existing standard in Edge, like Edge MEC, and then 1M2M. They are representative of standardization for IoT, and then Edge computing. And then there were some fundings, and then to collaborate, and then standardize those continuum between Edge and then IoT platform. So those are engaged companies, and then the achievement, or the objective is to provide handover, and then the Edge, IoT instantiated Edge computing is following wherever you goes. Those are kind of the concept that that project is trying to achieve. And then also, as you know, AI data is very important. And then in order to have successful AI training model, AI model, trustworthiness data is very important, right? So that how to make it. So in Edge, we, some of the INPACE members collaborate each other and then try to standardize how to measure the trustworthiness of data. And then not just simply defining the terminology, but also we are defining like equations, how to measure formally. And then it will be standardized as Edge standard. And then based on that, we are also building actual, open source based validation tool, so that whenever you have data and then you want to use it as a training data set, then you can test your data set, whether it is achieving or it has good completeness or it has good redundancies and so on. So those are one of the, also one of the project that is working on under the INPACE project. And then you can see several main contact. So Svetlana is the main leader of this INPACE project. And then also based on the region, we have sub-leaders, and then all the partner members are here. So if you are interested in, please visit INPACE Hub. And then also if you have any questions or want to get any information, please contact me or any members, any partners appeared in here. Okay, that's all.
Thank you very much indeed. This is a very interesting project. We also had the pleasure of working last year together in Tokyo for the EU Digital Week. Since INPACE is running already 2 years, and when you're writing proposals, there are different challenges that are relevant at the time. Have the challenges for your project changed in the meantime, and what are the priorities for the years ahead?
Well, now, as you said, already 2 years passed. And then we only have like 1 year and then around 3 months or something like that. So based on our previous experiences, now we try to, prioritize some of, the important topic with, for example, South Korea, because with South Korea, AI and then 6G is very important. So for example, we will have the similar, conference and so on, but the focus will be more, deepening real need. And then also we want to have some sustainability using this INPACE framework, so that we will try to connect to some government agency and so on, and then try to make what would be the good topic to collaborate between Europe and then those partnership, countries, so that we hope that we provide some guidance or insight to those government people and then planning people, so that they can use our deliverables or our insight to continue their collaboration, government level collaboration, or define some regulation and so on. So those are our remaining priorities.
It's always keeping the insight relevant and up to date.
Yeah.
Great. Thank you very much. The big thanks to the other speakers. I will now give the floor to my colleague Daniel. Thank you very much.
Thank you very much, everyone, for presenting the projects and the impact we are creating already across the regions. And as we draw this event to a close with the bravest of the participants, it is time for some final reflections on the insights shared today, but also as well yesterday. And to provide our closing remarks, I would like to invite to the stage Maria Angelique Evliati of RISE, but also John Gill Ko, Associate Professor at Yonsei University, together share the stage.
Thank you. Shall I go first? Go ahead. Okay, thank you. Okay, so just wrapping up what we have been doing today, we have exchanged on emerging technologies and we have concretized future directions for what we are trying to make an EU-South Korea collaboration. We started off, if you remember this morning, with Thomas explaining for us that the focus on Cloud-Edge and IoT, in particular in our research and innovation roadmap, has shifted fundamentally because of agentic AI. And that's based on the concrete feedback we are getting from the Nexus Forum community we have developed across Europe and working groups, actually reflecting what's important in Europe right now. We talked about how AI is reshaping cybersecurity and open source at a very high speed. And we also talked about how cybersecurity is shifting from endpoints to the network itself, to what Iraklis very nicely described as the mom in the room taking care of all the computing continuum components. We also had some insights about quantum computing. That remains a long-term and high-risk technology, but very strategic, requiring shared infrastructure and more policy development in order to enable collaboration. Finally, at the panel we had a while ago, we talked about how to secure global leadership in AI. I think it was made clear that we can no longer rely on building better models. We need to address the bottlenecks across the full stack, from energy efficient hardware to software and talent and all the things in between. So looking ahead, we talked about also some promising technologies. We talked about neuromorphic memory architecture, among other things. And I believe we all could agree that EU and South Korea have many similarities on the situation right now. We're all working to become more sovereign, more independent in relation to the US models. And there is a solid interest to learn from industry and the academia. My impression from what I've seen, both across the panels, but also the discussions I followed at the coffee breaks, is that we have achieved our goal as a project, and also our goal for these 2 days to bridge the computing ecosystems between EU and South Korea, to help align our priorities in research and innovation, and to also actually provide concrete input for future funding based on what we both in Europe and South Korea think it's interesting and what we are strong at. So I really hope that all the connections we've made throughout these 2 days won't stop today. I hope we can stay in touch and build further, turn these into factual projects. And with that said, I want to thank very much all the speakers, moderators, and last but definitely not least, John Gill and his team here at the Yonsei University for hosting us here and making this happen. So thank you very much, and over to you.
All right, so I guess the purpose of this meeting here for the 2 days and also at JCCI the day after tomorrow is to kind of show you guys the so what we're doing here. Hopefully you got to interact with some of the researchers in Korea, and kind of pick their brains on what they're really interested in and how we can modify our roadmap at the last minute to align the interests of the two countries, and hopefully that goal has been reached and will continue as we discuss with the people that we met here. JCCI will be more of a dissemination opportunity for us. And I hope you guys enjoyed your 2 days here. I will try to pinpoint all of you to some nice places to visit over the afternoon today before you go. And with that, I'd like to thank you very much for your time here, and thank you for coming to Yonsei. Yep.
Thank you both for the lovely words. As we also close the event, I would say the one message stands out, and that is the collaboration is no longer optional, it is essential. And I'm happy that we have also confirmed that and started doing that. As well, I want to thank the EU delegation to the Republic of Korea for the support, the Korea EU Research Center as well for a humongous support that they have provided, all the agencies and ministries of the Republic of Korea, moderators and the speakers as well for sharing all the insights, and the Nexus Forum partners and consortium for the months of collaboration of making this happen. Yonsei University for their hospitality, and especially John Gill and his team. You were really, really wonderful, and I would like a special round of applause for the team that catered to us these 2 days. You were really, really great, and you are the future and the reason also why we do this. So huge applause for them. And of course, we hope that we will be able to host you in Europe. In the meantime, we will have the Nexus Forum final event on June 16th. It is going to be at 10 a.m. Central European local time, so around 5 p.m. for you, if you would like to join after work or after your studies, to hear all the results and recommendations that we have for the European Commission, and also the ways this will come, those insights and everything that we spoke in these 2 previous days and the previous 2.5 years, how that will come into fruition. And also thank you all for joining. And I think we will also, besides this formal farewell and closure, there is also going to be still some coffee and cookies for us to enjoy and to network. And of course, I would like to invite to the stage the Nexus Forum consortium just to take an official photo so we can claim costs. Thank you very much.